Good morning, everyone. For those of you that don't know me, I'm Kelly, one of the conference organizers, and I would love to welcome you to DevOpsDays Vancouver 2017. We're pleased to be back at UBC Robson Square again this year, a venue that treats us well, for a fun-filled 2 days. We'd like to kindly ask that you make as much room for people as possible to make sure they can come sit next to you here, and also to our friends in the second room, where these talks are also being streamed courtesy of our partners at Extra Environmentalist Live Broadcast. They're up there. Thanks, guys. We've done our absolute best to accommodate as many people as possible again this year, so make sure you let people sit next to you and settle in for the great content that we have lined up. In the spirit of helping others and being inclusive, we continue to strive to make sure that this conference is a safe and welcoming environment. When we present, when we discuss in open spaces, and when we attempt to make conversation while also attempting to inhale lunch really quickly, a safe environment is key to our event. Behavior outside of our guidelines, which were presented on registration and should be again up in the lobby this year, will not be permitted. On your badges, there is a number that you could call or text if you see any issues with code of conduct violations. We hope this is never needed. In fact, I don't think we've ever needed someone to text. But if you do, we're letting you know that we have a very friendly organizer, Jared, ready to take messages from you. It is important that to everyone here that this is an awesome, safe space for everybody. Everyone here belongs here. We have different experience levels, from seasoned veterans, I see some nods like, yeah, that might be me, maybe, to eager newcomers. We have programmers, and we have operators and unblockers. We have those pointy-haired, and those juggling timelines or project plans. Some of our roles change over time. Sometimes we move from one to the other. We have a very diverse community of people and skills. As you go about your day, do your best to empathize with people's situations and opinions that may be different from your own. Support one another. Again, everyone here belongs here. This is our 4th DevOps Days Vancouver. We've come a long way, and I've been fortunate enough to see this event grow over the years. It holds a warm, fuzzy place in my heart. 3 conferences ago, our first conference, I wasn't sure I had much to offer. I don't even know if I knew what this event was about. But I came as an attendee, eager to hear what you, the community, had to say. 2 conferences ago, some of the lovely organizers you see here convinced me to give my first public technical talk. It definitely took some convincing, but you all were very welcoming, so thank you. Last conference, I had the lucky chance to help as one of the organizers and work with some of the sponsors on getting this conference funded. I'm super pleased to see some of them back again this year, as well as the new ones too. Welcome. And today, with the support and encouragement of the other organizers and Chris, I have the pleasure of seeing all your smiling faces as we open this event. What always strikes me about this event is a sense of community. We are tight-knit. We're funny and talented. While we don't always have time to be involved, when we do it wholeheartedly. To everyone returning, thank you. This event only exists with your support. To everyone new here, and all those from out of town, welcome. I look forward to meeting you throughout the day. Through this event, I've had the pleasure of making new friends and working with a talented team. I've made new connections and lasting friendships, as I'm sure you will today. To all of you here, I can't wait to see what new perspectives you provide, what challenges you face, and what experiences you have to share later in the open spaces. I'd like to take a moment now to thank our sponsors, companies who've helped us make this conference work. Thank you to our gold sponsors, Atomic, Boeing AeroInfo, Deus, Demonware, Pivotal, Salesforce, Sauce Labs, Sumo Logic, TriNimbus, and VictorOps. You'll be hearing from them a little bit later on. Thanks also to our silver sponsors, Chef, NetApp, Scalar, and Unbounce. You too help make this conference special. Thanks to our bronze sponsors, IT Glue, OpsGenie, Samsung, SAT Search Analytics, and Sourced, who also sponsored these snazzy lanyards you see here. Thanks to our coffee sponsor, Electronic Arts. Cheers to that. They've helped make my day possible. And we'd like to thank also our friend sponsors, and these are smaller companies that still want to be involved and support our community, and that would be AY Technologies and AdaptTech. Even our code of conduct phone service that I mentioned earlier was provided by Voxter Communications as an in-kind sponsorship, so thank you again this year for continuing to take care of us. Speaking of taking care of us, most importantly, I would like to thank those in our community who have really stepped up and spent countless evenings volunteering their time to organize this conference. So we've got special thanks to Ronald. He did all of our graphics. I see you, Ronald. Including t-shirts and logos and programs and the lanyard design and the badge design. You know, he really helped bring this conference together, and particularly through the last mile and even the last minute. Thank you, Ronald. Sim continues to help us with the money man, accounting, yeah, he's laughing, accounting, ticketing, event menus, this venue here today. Michael helps us with speaker proposals, open spaces, and menu wrangling. He's the one, I think, who roped me in the first place to this awesome event. We have an excellent team working on sponsorships this year with Kyle and Nadir and Amin. They really had things covered. Extra thanks to Vincent for continually updating our website as things went on. And Ben and Jared were both newer comers to our team. They did an awesome job just jumping in and helping out wherever was needed. We have our loyal day of crew members as well. We have Laurent and Colin and Frederick, as well as Jillian joining us today. So thanks to all of you very much. And Chris, as always, continues to be a huge supporter of this event, helping to bring in others and ramp them up on making this event a success. So thank you, thank you, thank you, all of you, for your hard work and dedication over the last 8 months. Remember, we're all wearing these snazzy red t-shirts today and tomorrow, so we are easy to spot. If anyone has any questions, don't hesitate to flag us down, and we'd be happy to help you. Also, don't be offended if we pass you on to another volunteer. We each have an area of focus to make sure this day runs well. Without further ado, we've got an exciting lineup of speakers eager to make a connection with you here today. We have topics covering security, service relationships, time to repair, sharing code with others, surviving the holidays or the workplace, and even zombies. Yeah. So we are happy to welcome our first speaker to the stage, Chris Van Tine. He's ready to kick things off with continuous security with Kubernetes. Come on up, Chris.
Good morning, everyone. Thanks you for attending today's session and having me, and all the sponsors who are making this event possible. My name is Chris Van Tine, Chief Technologist for North America on the West Coast at Red Hat, and I've been with Red Hat for about 12 years working with strategic partners and customers along the coast. And today's talk is about continuous security with Kubernetes. I'll be talking about DevOps, some of the drivers behind it, as well as how Kubernetes enables DevOps, and then talk about some of the security implications of a Kubernetes containers-based environment. So does anybody recognize what this is a photo of? Close. All right, this is the Tesla automobile factory. The reason I show this is because software is a huge part, not only of this factory and the production of the vehicles, but for the first time you can buy a car, drive off that dealer's lot, knowing the car will actually get better in 6, 12, 18 months down the road, because they're able to deliver software updates over the wire. This allows Tesla to quickly respond to customer feedback and competition and deliver improvements to their vehicle long after it's been sold. When you look at the enterprise, though, are they able to respond that quickly to the market and changing conditions? No. Our stats show that 6 to 9 months is the average to take enterprise to deploy new applications. And what is the common process or the common themes that are driving, enabling the enterprise and kind of causing these roadblocks is that we see that there's walled off silos or organizations, making it very difficult to move those applications from dev test into production. Also, these silos have evolved with their own set of processes and their own set of tooling, making it difficult maybe for the developers to communicate with the operations folks and vice versa, or the operations folks not being comfortable with the tooling that the developers selected. And so these types of challenges make it very difficult to move software quickly from dev, test into production, so a matter of months rather than a matter of minutes or hours in a DevOps type of environment. And so there's a lot of increasing pressure in IT to keep up and not become the bottleneck. And so you're seeing an evolution in how applications are developed, the underlying application architecture, as well as how they're wrapped up in a container, as well as the underlying infrastructure. You're seeing a shift away from waterfall development model to DevOps, a shift away from deploying monolithic applications to uncoupling them with microservices so they can rapidly be deployed, reduce the risk, as well as packaging these applications in a lightweight container that can quickly scale up, scale down, and be deployed into your infrastructure, whether it's private or public cloud. And there are a lot of companies out there that are early adopters of DevOps, whether it's LinkedIn, Etsy, or Amazon. But one of the common themes you're seeing is that as they adopt DevOps in their organization, they are able to improve the number of deployments that they're able to get out into production. They're having shorter lead times. They're having a lower rate of failure of deploying those into production. And when there is a failure, they're able to recover quickly from that failure. And so what is the enablers to DevOps? Right? It's not just technology. It's also a huge part of it is the culture. There's also process, as well as the underlying technology. From a culture perspective, it's all about having an open organization or bringing together the different disciplines, whether it's a developer, a tester, a security engineer, and operations together in collaborating, together having common goals and working as a team. From a process perspective, adopting continuous integration, continuous deployment with pipelines, enabling you to quickly move applications from development into testing to get immediate feedback as there is an issue, and then moving that application into production in an automated fashion. And then as you look at these early adopters, some of the underlying technologies that they're using, one of the common themes is that they're open source based in many cases, whether it's Linux and containers, the IaaS infrastructure orchestration, and the development tools that they're using to make an automated software factory that allows them to have automated builds and automated deployments of their software. And containers are a big part of this new software factory in DevOps. They enable you to package your application once with all the immediate dependencies and deploy anywhere, whether it's dev, test, or production, physical, virtual, or private or public cloud. And the basics of a container is that you build your container. You can specify in a blueprint or a Docker file exactly how to build that so it's repeatable, and you can version control it from a security perspective as well. And then also, there's the concept of being able to then take that image and share it, right? Share it amongst your dev, test, and production environments so that that artifact remains exactly how the developers intended and built it in development. When you put it into test and production, it's exactly the same. You're not rebuilding, you're not reconfiguring, and you're not introducing that risk of change or error or a security issue as well. And then also running, right? Running that in a standard container runtime, using that standard container image format, and being able to run that on physical, virtual, public, private cloud. Think of similar in the Java world. You have a Java runtime, the JVM, and then you have the jar file, so you're able to run that code on the JVM. In container world, it's not just Java, it's any language or any application can be deployed in a container image and then instantiated at runtime. And how about continuous deployment, right? That's a key part of this new software factory. In a traditional CI/CD pipeline, you're typically building a jar file in the Java world and then sharing that artifact in QA, staging, and production. With the container-based model, the artifact passes along as a container image. And the difference is it includes all its dependencies, the base image of the operating system and any other dependencies or libraries that the actual container needs. So as I move that artifact into test, into production, I have all the same exact versions and those components that were built in development. And containers, container images, container runtime are great for an individual laptop. But what about the enterprise when you're deploying these applications that are containerized at scale, right? In a cluster on a private cloud or on a public cloud. And that's where Google took their internal technology and open sourced it as Kubernetes. Kubernetes is a container platform for automating the deployment of containers at scale, handling the networking, the storage, and the compute scheduling of your containerized application. And we'll talk in more detail about Kubernetes. OpenShift is Red Hat's open source upstream implementation of the Kubernetes and Docker. And so one of the things, with the containerized environment with DevOps is what about security, right? Traditionally, security has been an issue for your operations folks, right? They've managed the systems, they've gone and patched. What's the issue with that is that not all these security issues are actually tested in dev or test. They're deployed into production. And so with a DevOps environment, really DevSecOps, you really need end-to-end security. It's kind of a new model of embracing security in the culture, as well as in the process, as well as in the technology, in dev, test, and production. And Kubernetes is a key enabler to automating this capability in dev, test, and production. So let's talk about continuous security. A lot of issues and concerns around security when it comes to containers, and in a lot of key areas. And we're going to go through these. First off, CI/CD. Builds, content, registry, the container host. And then secondly, we'll get down to network isolation. We'll talk about storage, API and platform access, as well as monitoring and logging, and federated clusters. So first off, CI/CD with containers. Here's a typical overview of the flow you'll see in a typical enterprise organization. They have their source code stored in an SCM with their developers and operations storing configurations as well as source code. Then you have your build in your development environment, your user and acceptance testing, as well as your production environments. These environments are mirrors of each other, right? in the DevOps world, one of the key principles is to give access to developers, give them access to production-like environments early in the process so that you resolve issues early rather than waiting to deploy that in a unique production environment. And Kubernetes is a key enabler to provide those mirror-like environments. And then you go ahead and build your container, and then you go out and deploy it into your environment. You'll save that into a registry, which will be the vehicle for sharing those images across dev, test, and production. And so one of the key things to a typical Jenkins continuous integration pipeline, as you're building your source code and doing these automated tests in a containerized-based environment, what you want to do is kind of enhance that CI flow so that it also includes a security scan of your container image. Right? You can do this in a couple of different ways. Maybe you have a registry which automatically kicks off a scan, or you add a phase to your CI pipeline that automatically runs a container image scanner, such as OpenSCAP, which is an upstream open source scanner that can scan container images, virtual machines, or physical hosts as well. And this is an important step because now if you integrate it in your CI process, right, you'll be flagging whether there's a security vulnerability in that image right away in development and tests, or is there an issue in terms of compliance to your security policy. So the scanner allows you to not only find security vulnerability, known security vulnerabilities, but also to check if it conforms with your security policy. And it is a great way to bring together operations or your security teams with the developers, ensure that everything that's going out of this software factory that's being built is also scanned from a security perspective. Also, continuous deployment. What are some strategies that you have in a containerized-based environment to take this artifact and move it from dev, test, and production, and roll it out at scale? So Kubernetes includes some deployment strategies to make this an automated process, so you don't have to write scripts. Your developers can get out of the business of writing a custom development pipeline and leverage an out-of-the-box open standard solution such as Kubernetes. And one of those deployment strategies is really around A/B testing. With routing, you can do some A/B testing on a Kubernetes cluster. For example, in this instance, I have application A out in my production environment. 100% of the load is going to that application, and I'm seeing about a 25% conversion rate for that particular application on the click-throughs on the website. Now I've gone ahead and developed another version of this application, and I want to test it and see what the impact is. Or maybe this is a security fix, right? And I want to see, does this actually have a negative impact or a positive impact? Does it alter the business? And so in this case, I can easily, with Kubernetes, deploy application B and change up the routing so that 80% of my load goes to application A, version A, and then 20% goes to version B. So I want to gain confidence of this new security update, perhaps, in production before I go all in. And so Kubernetes has deployment possibility to actually deploy this in a 20/80 split. Once I am comfortable with this new version, I can actually then switch it over to 100% on application B. Another deployment strategy, we'll talk about how you have zero downtime deployments with Kubernetes. Right? In this particular instance, I have version 1 out into production on 3 different nodes, and I'm developing version 1.2. It's going through the CI process, through a new pipeline through Jenkins, and once it completes its security scan and its testing, I can go ahead and do a rolling update. Right? So rather than going all in on this new version, similar to the A/B testing, but I'm actually going to deploy version 1.2 to 33% of my environment. Once I monitor and get feedback that that is a successful deployment. I'm not seeing a negative impact from a security or functionality perspective out in production, perhaps. I can then roll up to 66%, 100%, et cetera. And I don't have to write scripts, et cetera, to do this. Kubernetes takes care of this very simply. Also, it supports blue-green deployments. So Kubernetes can easily span up another environment completely separate from the existing environment. So the blue environment, for instance, is having version 1. I'm getting traffic on that, and I'm developing version 1.2. So I can go out and create an entirely new virtual instance of this environment, which contains 1.2. Within that separate environment, I can go ahead and complete my testing. Once that testing is successful, both from a security and functional perspective, I can do a complete switch over in my software load balancer that might be updating my F5 load balancer and route the traffic to then that new separate environment, virtual environment that hosts 1.2. And so this allows me to quickly roll back as well if there's an issue in that new environment. Maybe it's a security breach, and I can quickly revert back to the blue environment. Right, so those are deployment strategies built in and integrated into the Kubernetes container platform. Now let's talk a little bit about containers and security best practices as well. You know, one thing about containers is really to treat them as immutable. What does that mean? That means separating your code, your configuration, and your data. Right? From your code, that's the container image. That's where your application and all your immediate dependencies, maybe the base operating system image built for that container. And then from configuration, these are your traditional configurations. Maybe it's the data center location, maybe it's a geography location, maybe typically save that in a config file in the, on the system. Well, separate that out. You could use Kubernetes config maps, or maybe it's the password to access your MySQL database. In that case, you could use a Kubernetes secret to store that. And that goes into Kubernetes etcd distributed data store and allows you to have that separated from the actual container image. And then thirdly, Kubernetes certainly supports traditional data services. I see a lot of customers actually storing their data in their traditional maybe Oracle or MySQL database that's outside of this Kubernetes environment for initial deployments. And then for newer applications, they may be leveraging the persistent volume support within Kubernetes to store maybe on MongoDB or some other scale-out type of database or even a MySQL type of database and contain that in the Kubernetes, or run that in the Kubernetes environment. And so persistent volume requests can be done by the developer and then fulfilled automatically by the Kubernetes environment, either in an automated or a manual perspective from the back-end operators. The other thing about containers is that what's inside that container matters. Your development organization may be pulling out images from the Docker Hub. Well, you might want to be concerned about what's inside that image that's being pulled into your enterprise. A while back, we ran a scan on all the containers, and we found that about 64% of them had a medium or high priority security issue, such as shell shock, heartbleed, etc. And so you want to be conscious of what's coming into the enterprise and have some sort of security process to scan them. And also, you may want to consider about where they're getting the content from as well. And another thing is not just when you pull down do you need to be concerned, but on an ongoing basis. You need to be concerned about security as well. Take a look. These are a C application, a Java application, Node.js, and PHP from left to right. And these orange boxes are the different components that were pulled in when the Docker image was built. Now the triangle might be a little difficult to see the number, but take a look at the JRE here on the second column at the top. The number there is 66. And that represents that there's been 66 security errata notifications since the release of RHEL 7 for the JRE. Right? So my developer downloads it. You can be rest assured there are probably some security issues down the road that need updating. So I need to have a process to constantly monitor this. And that's why integrating the security scan in your CI process is a great idea to kind of catch those issues, or to integrate it with your private registry as well. Some best practices around building your Docker images, treat them as a blueprint, right? So that you have a recipe to rebuild that Docker image from scratch, right? Don't log into the live instance of the container, make configuration changes, and save it, right? It's impossible to reproduce or know what those changes were made later down the road when that engineer leaves and takes on other responsibilities. Also, version control your Docker files, right? Put them into a source code repository so you have those version controlled, those changes. And when you're specifying which components to use in your Docker file, be explicit with the version. Just don't put latest, right? What is latest? It could be different every time you run. Key is you want to be able to reproduce things, especially when it comes to security. Right? When there's a security breach in a PCI data area and you want to reproduce what logic was maybe run perhaps against that particular data set, you want to go back to that exact configuration, including that exact Docker image. And then be careful when you're using the run command in your Docker files, because every time you specify that, it creates a new layer as well. Also, some newer developments is around image signing, right? Sign your images. Red Hat provides support for image signing. There's many different solutions around this. And so Kubernetes integrates with image signing, providing the ability to detect, who provided the image, where did it come from, has the image been altered, right? So this provides another level of security. Another best practice, is building out a private registry. In OpenShift, we have an integrated private registry. Upstream, the Atomic registry is available, which allows you to host your image registry within your firewall so that you know who's putting things in there, what's going in there, and providing role-based access control as well. So best practice, certainly in an enterprise type of environment, to set one of these up. It doesn't mean that your developers are restricted from going out to the public and pulling things down. You can definitely enable that as well so that you're not stopping innovation. Also, from a host perspective, what are some best practices around container hosts? Right? One of the key things is, when you install images, what you may not know is that that image is typically running as root. And in a container environment, if there's a security issue, it's running as root. They not only have root access to the host, but then they also have access to all the containers on that particular system. So you want to be very careful about what you're running your images as. Also, limit SSH access into these containers. Really go to an API type model where you're always accessing things via an API rather than logging into a particular container or host. And then also make sure using Kubernetes namespaces, whether it's networking, so separating out networks and isolating networks for one container to another, providing high security in a shared environment. You can also define resource quotas so you don't have that bad neighbor behavior, right? Preventing that from sucking up all the resources on a particular host and negatively impacting other containers. Logging from an auditing perspective, you want to have that enabled. Be sure to apply security errata, not just to the container image, but also the hosts that they're running on. And then security context and SEC seccomp filters. This allows you to define policies So when containers or pods are initiated in the Kubernetes environment, it's well defined what the security context is from a user ID, group ID, et cetera, those containers are running as. And so Kubernetes provides support for that. And here's an example of the security context, right? It allows you to set those UID, GID, or SE Linux roles as well, and it'll apply those automatically. So this is a template that can be applied across your pod, and you can have different contexts for different clusters, et cetera. Right, so we talked about CI/CD, builds, content, registry, and container hosts. Now we also talk about network isolation, storage, API, monitoring, and federated clusters. Network isolation. So a great thing with Kubernetes and enabling DevOps is it allows network namespaces. Network namespaces are important because now you have network isolation from a security context in your different environments or your different containers. For example, you can set up a different network namespace for your development environment versus your testing versus your production. So essentially that means you have the same infrastructure, but 3 virtual different environments that are exactly the same. This allows you to enable developers to quickly spin up their own production environment in testing so that they're testing on a production-like environment. You don't need that standby data center anymore physically to test out changes in a production environment. And so this is a key feature that the enterprises drove and put into Kubernetes. Also, storage security, right? Kubernetes supports persistent volumes so that you can take your existing applications that are stateful and put them into a container, right? Even if you have your web app application with a MySQL data store, you can put that into a container. It doesn't need to be a stateless application that's newly developed. And so security context constraints allow you to limit who can access these storage volumes, as well as you have the ability to define quotas, right? So they don't negatively overflow the storage, and it's controlled in terms of how much storage they're requesting and being granted in these persistent volume requests. Also, these platforms are all API driven. At the Docker layer, the Kubernetes/OpenShift layer, you want to be able to not just have open access, but actually have authentication and authorization to these APIs and limit what folks in your enterprise can actually have access to do, et cetera. And so Kubernetes provides built-in support for role-based access control to the APIs so that you can define the policy and then limit what either a service or actually end users can be doing at the API level or the command line level as well. Another best practice is to take advantage of the built-in logging, right? So that you have an audit trail for what's going on in your Kubernetes cluster. Whether it's Kibana and Elasticsearch, these solutions actually run as a container on top of the Kubernetes environment. So they get all the same benefits for your other container applications, such as deployment, rolling updates, high availability, et cetera. And then also built-in monitoring, whether it's Prometheus or Heapster, Hawkular, on the OpenShift side with the Cassandra data store, you want to have access to all the metrics and have, from an ongoing perspective, historical perspective, but also have the real-time monitoring and logging capabilities so that you can search and scan for particular events or trigger events as well, and get a nice dashboard of your containerized cluster from a monitoring perspective and helping you identify security issues potentially as well. Another key capability that's under active development is around federation. Right? Federation is another key feature that from a security context. Allows you to kind of separate potentially environments. You may have your dev test environment out on Amazon, and so you could have Kubernetes running that. And then also, maybe internally, for your production environment, you want to have it on a private cloud, such as OpenStack. And so Kubernetes with federation can be deployed multi-clustered across these different infrastructures. Another implementation of federation is also you could have a single application spanning across multiple availability zones. In this case, the availability zones are different cloud providers, whether it's Amazon, Google, etc. And providing a global API to your Kubernetes cluster that spans across all of these environments. And so that's federation. So I want to thank you for attending today's session. Thank you for having me here at DevOps Days Vancouver. Really appreciate the opportunity to come and speak with you. I am available here today. I'll be around after the talk. You can also reach out to me on my email address or find me under Chris Valentine on LinkedIn as well. Happy to follow up and answer any of your questions on security, Kubernetes, containers, etc. Thank you so much.
Thank you very much, Chris. Awesome job. So next up, we have the largest talk by headcount. We've got Dmitrio Diachuk, Gordon Klock, and Roman Lizagor to share their viewpoints on compute choices in modern infrastructure. I also missed, our speaker gift for Chris. He made a break for it. Thank you, Chris.
Yeah, thanks. Hi, I'm Gordon Klock. I'll be giving the talk this morning. Dimitro's in Berlin, and Roman just had his firstborn, so they unfortunately couldn't make it. We are the founders of Pax Automo. This is a new startup we're doing this year. The bulk of this presentation actually comes out of a question. You know, when you first do a startup, you have to do, you're supposed to do, well, there's all these wonderful books on, product research and market research and things of that nature. And this question actually came out of our trying to do that exercise for our little venture. So the question that we were trying to answer was this, one of the economics of, when does it actually make sense to build your own infrastructure? It's pretty crazy nowadays, right? Like, when I was a kid, having exclusive access to a computer, it's nuts, right? Now you can plunk down your credit card and, spin up 100 or whatever the API limit is on Amazon for your given account or whatever, and then you just email the salesperson or whatever. So it's definitely much easier to provision very large computer systems, but there's still an ecosystem of, build it yourself, order things, and there's various things in between, right? Of course, you can, there's contracting companies you can call up, and they'll actually put all the physical infrastructure for you together. You're just responsible for the software stack. So the question then becomes, well, when does it actually make sense to do this? Because of course, we all know there's quite a lot of hassle. You've got to, order the computers, which is a big upfront expense, and you got to put them somewhere, power them, and then you have to actually take care of the software stack. So obviously, that's more than just spin up the instance on Amazon. This is I don't know if we almost didn't include this slide because, especially in the smaller sort of DevOps community, tends to be, okay, just do it in the cloud. No one wants to change SSDs. What is this crazy stuff, right? And within, larger organizations, it's like a tenet for a civil war almost between some departments or whatever, especially if you still have that dev versus ops split. It really shouldn't come down to that. I mean, there's the thing about what we're talking about is this economics problem is that it is really just about, what the cost of the CPU cycles you're using is and the memory and interconnect. I mean, you might have other organizational priorities that makes you favor one choice over another, but if you want to get right down to it, it is really about that. this is not a new problem. There's sort of kind of two things that we, talk about. So we talk about utilization of the resources, which is, how you're actually using the computers or instances that you're buying. But related to the cost is obviously your ability to forecast that. There's a duality between those two things where if you can't forecast out into the future, you need to buy more than you're going to use, and then your utilization is going to be lower, right? So please think of the polar bears. It's not just economics or whatever, right? I believe the figure is 1% of all electricity used in the world is being used by data centers, and it's one of the fastest consumers of it. We'll see with electric cars whether that holds true, but it is definitely a big deal. So the utilization of computers, this part it applies whether or not you're considering building your own infrastructure or you're using Amazon instances. I've heard it referred to as the bin packing problem, which is how do you get more of your individual processes that make your application onto the same instances. There's, obviously you can save some money that way or whatever, but even in the cloud, it actually does make sense sometimes because you tend to, with the fatter instances, get more bandwidth and you're not necessarily dealing with your noisy neighbors or whatever. In the kind of data center space or your own infrastructure or whatever, we've tried to solve this problem in the mid-2000s. It actually is the technology that gave the public cloud or utility computing its future or whatever, right? Was the kind of virtualization or whatever. And in retrospect, thanks to containers starting to become prevalent and stuff like that, it's actually kind of a crazy solution to kind of an insane little problem silly problem that we made for ourselves, right? Since it's mostly about resource isolation, which the C groups takes care of, and the namespace isolation, which is another thing from the containers. Like we ended up virtualizing Linux on Linux, and it's like, why, right? This is my conjecture. It's better to actually work on fixing the packaging in your deployment, like the orchestration. Use Kubernetes or Mesos or whatever to actually schedule your processes on those machines. Try to get to fatter instances and things like that before you worry about whether you're going to build a data center or kit out a colo area or whatever the problem might be. The other thing is, I mentioned this duality of, if you're going to have really low utilization if you can't predict your future, and effectively deciding to do a colo or to build the data center is an investment decision. It can be fairly substantial, right? It's best not to go into that blind. So if you're like in your very early phase of a startup, say, you're going to have it's going to be very difficult for you to actually predict your resources, but as you, like how much resources you'll actually need for your application. As you get a little bit more mature, and definitely as the scale goes up or whatever, it becomes much easier to actually predict what your demand is going to be. So the metrics that you need for it, and that's actually the metrics of just operating computers. They're covered in the systems performance book from Brendan Gregg. So check that out or whatever. It's like CPU cycles, CPU time, memory utilization, that sort of thing. You should be able to answer those questions about your service anyway. It's kind of like, I used to tell interns that one of the red flags for whether or not you should stay at a job is that if you show up on day one, they hand you the source code as a zip file, or worse, tell you to log into the server and edit the files on the server. You should probably just ditch that internship, go somewhere else. Similarly, if you show up at a place that it's operating an online service and they have stated SLOs or SLAs and they're not actually measuring how much requests they're getting and how much CPU time is being used, it's probably a red flag for a long night. So the thing is too with capacity planning is that it's very much like an academic discipline. There's fancy papers and all sorts of things about that. Dimitro, and that's actually what Dimitro does for his career, He suggests the art of capacity planning, which actually is not that. It's quite a bit more straightforward or whatever. And, it advocates you can probably just take shorter or like fairly simple things that you can do with Excel, like plot trend line or whatever, and use that to actually do your forecasting if you're not at the stage where you're going to be able to do more complicated things. So. There we go. So yeah, there is definitely a scale component to this as well, and that's mostly driven by your investment decision, like your horizon for how much you invest. Obviously, if you only need 2 instances or whatever, Amazon is definitely going to be the place for you. Once you start getting up there or whatever, it might make sense to start building the infrastructure. That's the question that we asked, was when that crossover point is. And of course, yeah, I mean, you're probably not. You probably have like an entire team working on this. If you're in I'm gonna go buy some land in, Oregon and build an entire data center or whatever. That's basically $1 billion investment, right? So we're mostly focused on the first two, that transition from the like public cloud to data centers, or perhaps you're in data centers and you're like, okay, I'm looking for a reason why we should be in the public cloud. This is not a very straightforward problem to answer. I mean, you can just go, okay, we're gonna, get this many cores in Amazon and this many cores in a data center and go, but it actually, that's a very simplistic way of doing it, and it's gonna lead to like somewhat strange outcome, right? Because I mean, we're supposed to be rational economic actors. It's the basis of our whole economy and all that wonderful stuff. Not really well supported by any actual measurements, but anyway, we have this idea that we should be able to do this. That duality of if you can't know your future, then you have to over provision. So when we were actually putting together this model of it, it's not enough to just go, okay, well, we get this many cores from Amazon, we get this many cores from in a data center, and hey, there we go. Here's our model. We could do that. It's too simplistic, right? Because of course, the whole benefit of the public cloud is you only allocate what you need when you need it, right? And you have things like auto-scaling groups that will actually let you do this without manually planning the capacities. So it's not enough to take the simple model and just go one-for-one comparison. You need to be a little bit more sophisticated than that. So what we looked at was, what's the effect of, we assume that you're gonna, to get the maximum discount from Amazon, you're gonna buy reserved instances for what you call your base load, or what we call the base load, which would be, if your service is, like, say, human-driven, as many things are, you have operate a web page or video games or whatever, right? Where the sun's moving across the earth actually determines, how much API traffic you're going to get, or whatever it might be for that day. And it's different. There's obviously other things. If you have an IoT model, then that's going to be a different demand pattern. You really need to understand that. For the purposes of the model we built to do this cost comparison, we chose to look at it from it's like a user, it's an online service for users that are going to have, varying demand within the day. You're going to use auto-scaling groups to scale that demand up and down to meet the need. You're also going to, though, have a base load. You're going to try and maximize minimize your costs on Amazon by buying reserved instances so that you're satisfying that. And then, of course, for the data center, you have to. We chose to do so. This model is actually fairly unfavorable to the data center. We chose to set the max utilization for the period of time at 30%, which is fairly low. We're only assuming you're actually running the online application, and then you're not backfilling your clusters with anything else. That's kind of an unrealistic assumption. I mean, if you're paying for the computers, you're probably going to try to use them as much as possible. Because of you can't just ask the Amazon API for more CPUs. If you're operating in the data center, you have to. There's lead time. It could be weeks, it could be months. If you're building, billion-dollar data centers, it's definitely years. So you have to over-provision, and you pay those costs regardless of the growth in your API or whatever. So we chose to use 3-to-1 ratio Dimitro's main remark on this is you can get this down. Especially as your service becomes more popular, your demand tends to become more stable, like law of large numbers or whatever. So it becomes easier to actually do to be more confident in your forecast, and then therefore not have to overbuy. So we were assuming the AWS M2 2x large instance, 100 gig volume with 750 provision IOPS. We're assuming you're going to back up your volumes on EBS to S3. We are not assuming that you're operating with a failover site, whether that's a different availability zone or that. It was quite a debate between myself and Dimitro, but whether or not that was a good idea to not include it. And then the S3 outage happened, and like a ton of stuff broke, and it became clear that it's like not an industry practice anyway. I joke a bit, but I mean, failover is actually not an option. You can't really guarantee this at the infrastructure level. This isn't to talk about reliability engineering, so I won't get into that in detail, but generally speaking, the app needs to do that, or the way that you route your users to your application. That's where that's going to happen. There's no magic infrastructure that's going to stay up 100% of the time. It's just going to work, right? So for the colo space, so again, we're assuming cages, you're in a purchase gear or lease gear. We wanted to make sure that the CPU memory and storage capacities are the same. We're assuming you're using some sort of distributed block store, whether that's, we think in terms of Ceph, but there's other options as well. And you're going to have 3 times redundancy in that. And because we don't have a S3 Ceph does offer a S3 gateway, but you probably don't want to back up Ceph to itself, right? Doesn't really make much sense. We have to toss a backup server into the model architecture as well. Okay, so because of that initial investment and your monthly reoccurring costs, up until you start getting into the hundreds of these M4X large instances, it's definitely cheaper to be in Amazon. So that's and $100,000 a month is beyond. I mean, I'm sure a lot of startups in the room are, that's crazy. Who would spend that much? It does happen though. So. And so that's the monthly recurring cost. And the crossover point is, okay. So the crossover point is, it's about 150 instances is when it really starts to make sense to be looking at, colo with again, with the assumptions that we've built into our model. When we break down where the costs are, and okay, this is not a shock to anybody who's actually done stuff in the data center space or worked with them before. The main cost is people. So what we actually did in the model, the model is fairly complete. It actually took Dimitro probably about like a week, basically 45 hours to build. We take into account all the crazy little costs that PDUs and cabling and all that stuff. We also added $500K per year for the additional operational expense of that or whatever. We were figuring 2 people at $250, but I mean the thing is you can break that down a lot of ways or whatever. You're probably not going to have somebody visit on site all the time or whatever, so you might use remote hands. That budget, I mean, we basically just allocated $500K per year for this. So that's actually a big chunk of, obviously, of it or whatever. The next big thing is the chassis cost. Generally speaking, bandwidth is much cheaper if you're operating in a colo than it is in Amazon. And the other part of it is I don't know know where Dimitro was pricing the electricity, but that actually plays a huge role. If you're going to try and kit this out in Japan, for instance, it's going to cost you a fortune. You know, like Oregon or Georgia or something like that might be significantly cheaper. So when we look at the AWS costs, the compute is a lot more expensive. Again, this is where you're able to predict, you know, a certain base load that you're able to buy as reserved instances, but you can't obviously do that for all of it or whatever. Or if you can, then you know you can make that significantly cheaper. The storage costs are mostly for the provisioned IOPS. I know there's ways to cheat by having bigger volumes and you know you get more that way or whatever, but you know, if you have SLOs and latency penalties, that might not necessarily fly, right? So, when we if you do decide to actually build this infrastructure in your you know, in a colo or something like that, you know, a lot of the attention in the DevOps community and elsewhere has been on the cloud because that's enabling, you know, a lot fewer people, these you know, DevOps teams to do a lot more with, you know, with less people, which is great, right? But the hardware space hasn't stayed frozen, right? A lot of stuff has actually changed in a while or whatever. So Paul and I, we worked at U of A. We did consulting for like high performance computing, and it's the sort of the modern way of designing hardware is like what was in the HPC space 10 years ago, which is a lot of it is to do with the networking. It's the foundation upon which you build everything. So if you screw that up, you're going to have a really bad time in your colo or your data center. And that's probably the reason most of us have had it. So it's software defined, like for everything. If you have a really big problem, if it's like your deployment plan is, you know, open a ticket with Team Foo or whatever to actually get the external service provision, you spend a bunch of time for no reason. The other big thing is that the big thing with so there's a right amplification factor. Even if you have an e-commerce site or whatever, you have, you know, your fairly simple, straightforward shopping cart, but then you're going to make recommendations about, you know, other things to buy, and you're going to have all these things. You can hopefully deploy those as microservices, or even if you're doing a monolith, you have one incoming request. The GET request is relatively small. All of a sudden, you're in your backend in the cluster. You're making, you know, dozens or hundreds or even thousands of requests to other services within that or whatever. The bisectional bandwidth, it's sometimes referred to as east-west. Like you have a process on this node here, and you want to talk to the process on, you know, maybe 3 racks, process running on a CPU maybe 3 racks over or whatever. The bandwidth by which they can talk dictates, you know, the performance of your application or whatever. So if that's a MySQL database, for instance, your query. So that bisectional bandwidth across the network is really important. Most old enterprise networks had this, you know, they had a lot of switchback planes in them, and the switchback planes are not really rated for the line speed of the. So you plug it in 10 gigabit, but it's like, you know, 1/72 of that between, you know, given nodes depending on the topology. So there's, you know, cross networking. I'm gonna go faster. The other thing is, you know, avoid complicated networking like VLANs and stuff like that as far as within the cluster. Use flat addressing space. Most of the enterprise value add stuff, it's just bugs. You know, you honestly, like, can you power cycle it? Does it boot off the network? Good enough, right? Like, you know, if you have something horribly wrong if you're spending all your time on some sort of weird keyboard, video, mouse console thing. The other big thing is lifecycle management of the hardware. If you're going to buy this, make sure you're not buying like, oh yeah, this week we ordered this model, next week we ordered that model or whatever. You know, you're buying something for 3 to 5 years. Spares will become a problem at some point, and if everything is different, for instance, this becomes kind of a huge pain. So this is a Coloss network or whatever. Cumulus Networks actually has some great stuff on their website, which you can go check out, including, I believe they have the GNS3. They have instructions for, there's something called GNU Network Simulator. You can go download that. You can actually set up a Coloss fabric in, you know, using GNS3 and some VMs that you can spin up, and then actually make sure that your network actually works. Another option, if you don't want to go Coloss, or I mean, it's ultimately a similar architecture, but InfiniBand, the per port cost is actually fairly low, so something to look at. For our racks, oops, now it's going ahead. We have, for the Colossus network, we chose these two models of, I'm not going to say the vendors because it's not pitch. There's two models of there's two spine switches for 5 racks. The top of the rack switch is actually the leaf switch. So these are crazy switches. Each one of those ports is 40 gigabits per second for the spine switch, which you can split 4 ways. The switch is less than 10 grand. I mean, the cost for most of your cost is going to be in the, I think they're QSFP plus, the actual physical connector in your cabling. And the switches all just run Linux, so you can automate them with Ansible or even Puppet if you're a masochist or whatever, right? Like, so we use these servers. We did actually build into the model like the power consumption. We kept the per rack at like 20 kilowatts, which should fit into the power envelope of most colo providers. And then for the backup server, this is nuts. This is like 90 disks, I think, for you. It's a petabyte, basically per rack. It's madness, right? I'm also not saying the vendor, but you can probably figure it out. Our conclusions, though, from looking at this was basically don't rely on axiomatic beliefs about infrastructure. Your infrastructure costs are approaching 100K per month. You're probably going to see significant benefits from doing the colo thing yourself. And if you can't forecast your demand, this makes no sense. Figure out your demand, right? All right. If you have any questions, you can email us. But I think we're basically out of time. Sure. Sorry, we're going to actually put this, so Dimitri developed the spreadsheet. There's lots of cursing about Google spreadsheets. We're actually going to make the spreadsheet available so people can copy it and clone it and put their own scenarios into it or whatever. This is going to happen next week when Dimitri's back from Berlin. So if you want, you can also, I think we have a Twitter account. I'm not a Twitter user, but we have a Twitter account. You can probably follow that, and we'll actually post a link to that when it's up. So thanks. Is it okay?
Does anyone have a question?
Sure.
I had a two-part question. You probably answered the first part, but wasn't listening. In your colo graph, where by the end of your graph, AWS is twice as expensive.
Yes.
Were you calculating for the extra hand that you're hiring in the colo to provision your VMs?
Yeah, so we did actually mention that we put a $500K budget in for that. That's good that you mentioned that part. There was one caveat with that. At some point, your spine cost for the switches becomes too expensive. It's like 5,000 instances or whatever. And at that point, Amazon, I should have, sorry, that's big miss or whatever. That graph continues, but that's just one snapshot of if you make the graph longer, it'll obviously, at some point, that particular network architecture needs to be substituted for another one. It's going to cost more money, right? So, your second part?
The second part was just also scaling the people that you're hiring. If you're dealing with 1,000 to 2,000
So your question was about scaling the people that you're hiring or whatever. It wasn't really in the purview of the talk, but of course, like that's kind of an organizational HR challenge for everybody. Even finding the people is probably pretty difficult now. Hyperscalers tend to hire everybody. But the thing is, if you do the sort of modern architecture thing correctly, you're not going to need people on site as often because you don't care if the drive failed because it's replicating Ceph 3 times. Somewhere else will pick it up when it fails and stuff like that. The hardware, you could have bad run of somewhat. There was a hard drive manufacturer somewhat famously had like a 30% failure rate or whatever. I think you can read about it on the Backblaze blog. So that could be a disastrous scenario for this or whatever, where your costs on site could get out of hand or whatever. So yeah, I'm not an HR professional, so I don't know what the how to scale the teams for that or whatever. I think the cost though is that 500K. It's probably in the right thing, up to like 10 racks, which is a lot of compute actually. There's one. So we put it at 2, it's 250K. Oh, sorry. You were asking, we put 500K per year for headcount, and what does that break down to? So we put it down for 2 people in our model, or that's what we were thinking would be that 250K per year is pretty high for even in Silicon Valley. That would be fairly generous. We were figuring you would need one person with an expertise in software-defined networking, and that we were assuming that your existing DevOps team would be amenable to, also doing the deployments on this. So if they're familiar with setting up Kubernetes in the cloud, they can almost certainly get it working on this architecture or whatever. And then the other bit of it would be the actual physical management stuff, whether you're paying a value-added integrator when you buy your hardware to actually do all the cabling, drop it on site, and do all the repairs, which is an option, and would fit within that 250K a year, I'm assuming. Or you're, every once in a while you're flying somebody on site to do the warranty or whatever, that kind of thing. So, thanks.
Wait. Thank you very much, Gordon. This is sort of a topic near and dear to my heart. Some of those stats definitely ring true for me, so thank you very much. Next up, we have a message from our gold sponsors. These are companies that have stepped up with generous financial contributions to help run DevOps Days. So let's make sure they come on down, gold sponsor messengers. I see them here. We are a not-for-profit event, so every dollar that goes into this event goes, sort of into running this or future conferences. Today we welcome to the stage Deis, Pivotal, Salesforce, Sauce Labs, and Atomic.
Thank you. Hi, my name is Derek. I'm with Atomic. We're long history as an enterprise batch scheduler around Oracle and SAP, and we do release automation and orchestration that's typically a little bit more IT operations friendly. So if you have any questions, feel free to stop by.
Hi, I'm Matt. I'm from Deis. We're here bringing off 2 different products. Deis Workflow, which is like a Heroku-like PaaS on Kubernetes, and then Helm, which is kind of like a package manager for Kubernetes. So we have got a booth over there. You're welcome to come along. We have got a demo available if you want to look up and kind of play around with Kubernetes or play around with the 2, Workflow and Helm. And we've also got a giveaway for a little Kubernetes Raspberry Pi cluster. So if you want to get into that, we have a survey that you can fill out, and you can join up for that. Thanks.
Good morning, everyone. My name is Bala, and I'm from Salesforce. And it's such an honor to be here and welcome you all to DevOps Days Vancouver 2017. I've been with Salesforce for a really long time, and I actually remember when I used to know the IP address of each and every server that I had in production about 17 years ago. And today, I think I've sort of lost count of how many data centers that we have across the world. And the reason we have been able to get from where we were to where we are is because of a huge number of very dedicated and smart engineers, just like you, who make all that automation happen. I have a lot of stories to tell. I'll be at the Salesforce booth outside for a little bit. So if you just want to come over and chat about Salesforce and what we are doing, I would be thrilled to have a word. Thank you.
Hi, everyone. My name's John. I'm from Pivotal. If you don't know, Pivotal is 2 things, really, an agile consultancy, and we are Cloud Foundry and Java Spring. So we are the main contributors to those open source projects. And our main mission in life is to help large, kind of traditional organizations to get agile at scale, to go faster. And we've been at this for about 20 years. We helped Google and Twitter to get their development operations off the ground. And now we're working with companies like Comcast, Boeing, Liberty Mutual, and Manulife. So we're having great fun helping them do that. So I'm here, Ben's here. We have a bunch of books to give away. So if you want to talk about cloud native, ops, development, Java Spring, Netflix OSS, we have a whole range of things that we'd love to talk about and show you and hear what you're doing as well. Thank you.
Good morning, everyone. My name is Alyssa. I'm representing Sauce Labs today. So Sauce Labs provides the world's largest cloud-based grid for automated testing. So we're here because we truly believe that the biggest bottleneck to achieving true DevOps is automated testing and infrastructure. So don't worry about building VM farms and maintaining browser and OS combinations or mobile devices. Let us take that off of your plate and make your automated testing more awesome. We are over outside there at a table. We're giving away bottles of our patented hot sauce, some bike lights. So I throw this in the crowd, but I want to hit anyone in the head. And we're also giving away a drone. So stop by, take a survey, shop on automated testing with us. Where we don't bite, I promise. And yeah, enter to win a drone. Have a great time at the conference, guys. Thanks for having us.
All right, we're about to take a 10-minute break, but before you go, coming up just before lunch will be the time that we think about pitching our open space ideas. So as you take your 10-minute break, it's a nice time to come up with an idea and think about a 1 to 2 sentence pitch about an idea you'd love to discuss with your peers. So seats are first come back, first served. See you in 10 minutes. Come on, grab a seat, grab a seat. Chinto, I see you. Sit down. No. Come on down, everybody. Last chance for coffee for 500 miles. Grab a seat, grab a seat. If there's not bags and things on it, it is probably safe to sit there. I read your mind. Come on down. All right, let's get started, everybody. So how many of you here have ever contributed to open source? Oh yeah, and I can already tell in my mind in the overflow room that a lot of hands have gone up as well. So today we have Nell Shamrell-Harrington here to talk to us about some of the trickier parts of working with open source. So take it away, Nell.
What do you think of when you hear the words open source? Well, since this is a DevOps Days conference, I'm pretty sure it's something positive, like altruism, free software, or community. Now, we have all these warm, fuzzy feelings around the ideals of open source, but the implementation of these ideals can be very difficult. And that brings us to the question, what makes a project open source? Now, I think for some people, a project becomes open source when it is uploaded here to GitHub. If it's public, it must be open source, right? Well, technically it might be, but in my experience, projects that stop here with being uploaded to GitHub tend to die. Sure, someone somewhere might use it, and I don't want to discourage you from sharing code to GitHub, but it is one thing to upload a project to GitHub and call it open source. It is quite another to commit to governing a community of users and contributors, to shepherding that project throughout its lifespan. Now, it almost goes without saying that open source governance is hard. That's frankly probably why you're sitting here listening to a talk on it. And the reason it is so hard is because in open source governance, technical and communication skills are intertwined. Both of these skill sets are constantly required at the same time. You cannot have a successful open source project with only one or the other. Now, the hardest parts of open source are not the technical parts, nor are they necessarily the people parts. The hardest parts of open source are the places where humanity and technology intersect. Now, even though these are the hardest parts, they are also the most vital. They are what separate a successful open source project, a project which evolves and grows and continues to expand its value, from an unsuccessful project which is shared to GitHub and then dies. Now, sometimes when I come to DevOps events like this, I find some people just desperately want to be told that embracing DevOps will magically make everything easy, that success in their business will suddenly become effortless. Now, unfortunately, even DevOps will never make running a successful business easy, but it will make it possible. Open source governance is very similar. It can sometimes seem like an impossible job. Even though it may never be easy, successful open source governance is possible. The reason I'm here today is because I have experienced this success myself, and I want to help you be successful in governing your own open source projects. And with that, I'm Nell Shamrell Harrington. I'm a senior software engineer at Chef Software. I'm also an open source contributor and maintainer, most notably on Supermarket and Habitat, which are both projects that come out of Chef. You can tweet at me at @NellShamrell or email me at nshamrell@chef.io, and I will put this contact info back up at the end of this talk. Now, in my experience in open source, as a user, contributor, and maintainer of multiple projects, I found the hard parts can be condensed into three main categories, and I call these the 3 duties of open source governance. And the first is to make it easy to contribute. Now, this might sound simple, but it's not simple when you realize how many different types of environments are out there. And the second duty is to assist users with the project. As the maintainer, you are on the front lines of answering requests for help. And then the third is to manage contributions to the project. Now, these might sound pretty obvious, and the ideas of them certainly are, but when you get into the nitty-gritty of implementing them in the real world, it can be anything but obvious. And that's what this talk is about. The hard things that come up in the real world when you are involved in open source governance. So let's start with that first duty, making it easy to contribute. Now, when we're experiencing those warm, fuzzy feelings around the ideals of open source, we tend to think contributing involves 2 things. The first is finding a project on GitHub, clicking that fork button, cloning that fork down to your workstation, and then making changes within that fork. And then next is you submit those changes in a pull request. Now, this seems amazingly simple from the outside, but there is a lot that happens in between these 2 steps that we don't always think about. In particular, one of the hardest parts of contributing to open source is getting any development environment set up at all, let alone one that is consistent with other contributors. And furthermore, once you have the development environment set up and make changes, you then have to test those changes. And if setting up development environments on inconsistent workstations is hard, running tests on inconsistent workstations is even worse. Now, some projects try to get around this by saying we only support certain types of workstations. And while this might help mask the problem of different development environments, it also significantly narrows down the list of potential contributors. And it therefore hinders this first duty of making contributing easy. Now, one solution, which I have seen be very effective, is creating virtual workstations that a contributor can spin up on their local machine. So this is a project I worked on last year around election time called Drive the Vote. The idea behind this app was to allow anyone who needed a ride to the voting polls on election day to be matched with a volunteer who would drive them for free. And what we did was we had a Vagrant file within our GitHub repo that allowed someone to quickly spin up a Vagrant box where they could do their development, one, with all the required versions of all the required dependencies already set up for them, and two, they could develop in a way that would be unlikely to affect their local workstation. This means that a contributor could be developing on Linux, Mac, Windows, anything that supports Vagrant, and by spinning up that Vagrant box, instantly be using the exact same development environment as all the other contributors. Now, another option, which we at Chef use with Habitat, is to include a Docker file that can be used to spin up a development environment. So this is the Docker file we have in our Habitat GitHub repo. This provides the configuration for a full development environment within a Docker container. And again, this means a contributor can be using Linux, Macs, Windows, anything that supports Docker, and still have the same development environment as the other contributors. Now, the key to make this successful is to commit to supporting the development environment along with the rest of the project. If the development environment breaks, that means the project is broken, and the first priorities of maintainers needs to be to fix it. In order to fulfill this first duty of making contributing easy, the maintainers of the open source project need to keep the development environment functional at all times. Now, once someone has their development environment set up and makes that change, they then have to test those changes. And as I said before, if dealing with different development environments is a challenge, running tests in different environments is nearly impossible. So the solution to this is to use a continuous integration service like Travis CI or Circle CI. This allows contributors to run automated tests in a consistent environment outside of their workstation and avoids those problems where a test passes on one person's workstation but fails on another person's workstation. So this is the Supermarket project, another project that's created and maintained by Chef Software. Now in this project, we have our Travis CI configuration set up so that every time someone opens a pull request, it automatically kicks off a test run on Travis's hardware. Now once that test run is complete, the results display in the pull request itself. It returns consistent results. And in open source, consistency is a sometimes uncommon but beautiful thing when you can find it. Now, even if someone has an environment set up where running tests locally is difficult, they still have the option to run them just by opening a pull request and seeing the results. It also makes things much easier for the maintainer when they're reviewing the pull request because they can instantly see whether those automated tests passed. So there is certainly more to making contributing to a project easy, but these two parts, setting up the development environment and testing changes, have given me the most grief historically. Luckily, as we just saw, there are solutions which make it easier. Maintaining consistent development and testing environments won't necessarily ever be easy, but these solutions make it possible. That's the first duty of open source governance, making it easy to contribute, making it easier on the contributor side, even if it is not necessarily easy on the maintainer side. Now let's move on to the second duty, assisting users with the project. As an open source maintainer, you are on the front lines of answering requests for help. And most of the time, they come through GitHub issues. These might be bug reports, they might be feature requests. Often they're a combination of both. Now, when the issue is a bug, The hard part is often replicating the issue, especially when your project has many dependencies and is used in many different types of environments. Now, the other hard part is sometimes the issue is not in your project at all, but is due to an upstream dependency of your project. This is also one of the hardest parts, and we'll cover exactly how to deal with that in just a moment. But first, let's talk about replicating an issue. It's especially hard to do this when the person who filed the issue is using the project in a different environment than you are as the maintainer. They might be seeing a bug that only shows up in very specific circumstances. Now, it's never going to be easy, again, but there are some things you can do to make replicating an issue faster and more effective. So let's look at a real-life example of this. This is Test Kitchen, another open source project maintained by Chef. Now, people not only use Test Kitchen in many different environments, they use Test Kitchen to test code, which itself is meant to run in many different environments. So this means the number of possible conditions where someone might see a bug is quite high. Now, when a user sees a bug, we need to know exactly how they are running Test Kitchen in order to be able to diagnose it. And to help with this, Test Kitchen uses a built-in template that auto-populates whenever someone opens a new issue. This lays out exactly what we as the maintainers need to know about a user's environment and tells the user upfront what information they need to provide. It's very hard to miss that you need to provide certain details when this template appears anytime you file an issue in the Test Kitchen repo. Remember, what might be obvious to a maintainer of an open source project is not always obvious to a user, and it's not the user's fault. It saves a lot of time and a lot of back and forth by stating exactly what you need up front where the user cannot miss it. So after reproducing a bug, it's actually fairly common for it to be due to an upstream dependency of the project rather than the code in the project itself. Now, in cases like this, I've seen some maintainers close the issue with words along the line of "not my problem." But if a problem manifests in your project, it is your problem, even if it's due to an external dependency. As a maintainer, it is your responsibility to, 1, communicate the issue to the maintainers of the upstream project, and 2, communicate that to the person or persons who filed the issue in your project. Additionally, you need to update the issue in your project regularly with the progress of fixing the upstream issue. It is your responsibility to keep your users informed and to let them know when the issue is fixed. Now, if the upstream maintainer is ultimately not able to fix the issue, or if you don't get a response from them within a few days, you need to consider changing the dependency. Sometimes a maintainer of an open source project will go dark. That definitely happens. As an open source maintainer yourself, you need to be prepared to change dependencies when needed. So there are certainly more parts to assisting users with open source projects, but these two, replicating the issue and dealing with upstream issues, are some of the hardest, but also some of the most frequent that come up. Dealing with them, again, can be hard, but it is possible. And that covers the second duty of open source governance, so let's go ahead and move on to the third duty, managing contributions to the project. Now, there are two main parts to managing contributions when you are an open source maintainer. And the first is determining whether a contribution adds value to the project. We'll go a little more in depth on exactly how to do that in just a moment. But the other hard part is when a contribution ultimately does not add value, saying no in a way which still supports the contributor and treats both them and their work with empathy and respect. So let's turn our attention to determining whether a pull request adds value. Let's first start with the easy things. Let's go over a few things that definitely add value to a project. And the first one I want to highlight is documentation. This is by far the most useful contribution for me to receive on any projects where I'm a maintainer. This is because there's no better documentation than what comes from someone who is actively using the project. When I'm a maintainer of a project, I become so used to looking at it and understanding it that it's really easy for me to lose sight of someone without who does not have my perspective, what they experience. Any contributions which make the experience easier for other users are immediately very valuable. And the next one is typo fixes. Now, occasionally typos sneak into projects. Hopefully not in the actual code that executes, though I have seen that happen, but most often it's in the documentation and instructions. Now, at best, typos make a project look unprofessional. At worst, they can make things like documentation downright misleading and make using the project harder. Again, as a maintainer, I've often been staring at that code and documentation for so long that my eyes just glaze over small typos. Too many typos make a project harder to understand, and therefore corrections to those typos immediately add value. And the last one is small bug fixes. This is another major thing that adds almost immediate value to a project. One of my absolute favorite types of pull requests to receive is when someone finds a bug in the project and reports it by fixing the issue in their own fork and submitting it as a pull request. So whenever a pull request fits into one of these three categories, things that definitely add value, I often merge it that same day, sometimes within the hour, because the value they add is immediate and demonstrable. Now let's talk about the flip side, because there are a few things that definitely do not add value to a project. And the first one I want to highlight is white space changes. This comes up more often than you would think. Unless a project has a style guide and you're correcting a violation to the style guide, white space changes do not add value to a project. My guiding rule is that if it does not violate the established style guide, leave it alone. White space changes, just for the sake of white space changes, cause merge conflicts for other contributors. And therefore, the value they add is actually negative. If I, as a maintainer, receive a pull request that only changes white space, I will not merge it. And the second one that does not add value to a project is big features if you have not talked to the maintainer first. And by big feature, I'm talking about more than 100 lines of non-test code. This is because it may not fit in with the plan for the project, or it may be something that is already in the works, but not yet public. It is truly heartbreaking to have someone spend a ton of time on a new feature only to have to close it without merging it because it's just not right for the project at that time. Large features, when a contributor has not talked to the maintainer first, do not add value. So now we've covered a few things that definitely add value, and a few that definitely do not add value, and it would be fantastic if all pull requests were this clear. But more often than not, pull requests are for things that sometimes add value. And things that sometimes add value include small features. This is something that's not a bug fix, but something that adds new behavior to the project. And again, I consider a feature small when it is less than 100 lines of non-test code. Additionally, sometimes even large features add value, but only if the person making the feature has talked to the maintainer beforehand. Again, it is heartbreaking when someone has clearly spent a ton of time and effort on a pull request, but as a maintainer, I have to reject it because it's just not right for the project at that time. So these sometimes add value and sometimes do not add value. So this begs the question, how do you determine which is the case at any given time? Well, when a pull request comes in and you're not sure of the value, it helps to ask a few key questions. And the first one I always ask is, does it fix an existing issue? When a pull request fixes an existing issue or fulfills an existing feature request, there is often value in that, especially if multiple people have requested the same thing. Now, the second thing to consider is if the pull request replicates work that has already been done elsewhere. Now, occasionally, multiple people will submit pull requests for the same issue. And then it's up to you as the maintainer to compare them and figure out which solves the issue in the best way for that particular project at that particular time. And the third question to ask is whether it affects in-progress work. If it is something that will potentially cause nasty merge conflicts with development that is already in flight, the value of that pull request might be negative, at least until that in-flight work is complete. The overall guideline is to remember that a contribution returns negative value when it makes other contributions harder. Even if it is something that might actually be the superior option purely from a technical standpoint, if it makes contributions harder or makes using the project harder, it does not add value to the project. Now, when a pull request ultimately does not end up adding value, it's crucial to, one, communicate that, and two, communicate it in a supportive way. Open source projects live and die by community engagement. If someone's first experience with your project is awful, chances are they are not going to come back and may very well warn others to stay away from your project. The key is to always, always, always say thank you. Even if a pull request is something I, as the maintainer of the project, cannot ultimately use, I need to recognize that someone went through the time and effort to put it together and submit it. That the person who opened that pull request is most likely a well-intentioned human being who has taken an interest in my project. In addition to saying thank you, always, always, always say why if you don't merge the pull request. There is little more frustrating for a contributor to spend a ton of time on a pull request, even if it's something they really should have talked to the maintainer about first, and have it just be closed without knowing why. It's frankly cruel to leave your contributors in limbo like that. So these parts of managing contributions, determining the value, and communicating that decision are some of the hardest parts of open source, because they, more than perhaps anything else, touch on that intersection of technology and humanity, both the humans using the technology and the humans creating the technology. Now, even though these parts are the hardest, again, they are the most vital. They are what separate a successful project, a project which lives and evolves and grows that people stay engaged in, from an unsuccessful project where engagement tapers off and the project dies. Now again, open source governance can seem like an impossible job, and it's never going to be easy. But what I hope you take away from this talk is that it is possible to be successful with it. There are tools and techniques out there that can help you, and the key thing, as always, is remembering that the people who make open source projects and contributors are people. There is a person behind the keyboard. Thank you. All right, again, that's my contact info, and I think we have a couple of minutes for some questions. Yes, sir.
As a maintainer, with those large contributions that may not match up, are there general practices or things that you've done in the past successfully to help guide people towards those large things that contribute large value?
That's a good question, and yes, often when, the question was, with things like large features, how do you guide people toward the ones that add value? So whenever a new contributor comes on, or someone's straight out of a coding boot camp and says, I want to get some experience in open source, what I usually do is go through the features and, or the feature requests, find one that might be large, but something that's going to add a lot of value, and then work directly with that potential contributor in breaking it down into achievable steps. That's a great way to, one, make sure that me, the maintainer, and then the contributor are staying in sync with what each other's using, and two, kind of guides them how to do that in the way that might be best for the project. Any other questions? Yes, sir.
How much time do you say you spend in an average day going through different pull requests and actually being a maintainer for Supermarket and Habitat? And do you feel that that's enough time? Do you feel like you should put more effort into it?
The question is, how much time do I as a maintainer spend on things like reviewing pull requests and such for Supermarket and Habitat? I have the luxury of being paid to work on open source full-time. So, and again, it was not always like that. It is a luxury. So I would say there's at least an hour or two of my day job which is spent triaging, which is not necessarily working the issues, but figuring out what people are seeing, where they're being replicated, and then reviewing pull requests. As for reviewing an individual pull request, it depends on the pull request. It's hard to give an approximate value of how much time I would spend on it, because it's highly variable. But yeah, at least a couple of hours of each of my day is spent reviewing things that come into that project, or those projects. Any other questions? Yes, sir. How do I handle requests for deprecation or removal of features? That comes up a lot at Chef. And I pretty much treat it the way I would adding a new feature, but there's more time that I'm going to spend to it because you need to add in a buffer for communicating that that feature is going to be deprecated. In Supermarket, we generally deprecated features with a major release. So we use semantic versioning. So if I was going to take a feature out, I would probably put that in something like version 3.0.0 rather than 3.0.1. So that way it would communicate to the person using the project that there's breaking changes. All right, I think that's all the time we have. I will be at the Chef booth throughout the weekend along with here. So feel free to approach me if you have any questions. Thank you.
Thank you very much, Nell. I know you were approaching it from the side of running a project, but at the same time, I think we all probably learned something about being a good contributor. I know I did. So next up, we have Bill here. Bill is just getting set up. Bill's going to talk to us today a bit about the state of DevOps survey and kind of what trends he's seeing and what that means for our industry. To the left, to the left. Can't help it. Oh, were you going to sing that part? Oh.
Killed the opening to my talk. All right, let's go, guys. Sorry for the dual boxing here. Speaker notes didn't quite work out, so it's me, Bill Weiss. I'm at Bill Weiss most places. I realized very late that that's not my email address at work. I'm actually bv@pup.com if you need me there. Anyway, I'm a people manager. I manage 2 SRE teams there. And I really believe, I'm a DevOps believer, as it says. I believe in this and what it can bring to organizations. So I'm here to talk about, DevOps. Specifically, the DevOps survey, the State of DevOps survey, which is done every year, and there are 6 reports released. There's another one going on right now. I'll have a link to it at the end. Important to note, this is not a sales pitch. I do work at Puppet. But this is not about any particular software. I'm not going to suggest one. Most of these things can be done with any software out there. If you want to talk afterward about which ones I prefer, sure. Feel free to ask questions as I go along if something comes up. Otherwise, I'm going to propose an open space about this topic so people can discuss it afterward. If there's interest, we'll do that. If not, just come and find me. All right, so and I want to get on some common terminology. I want to get on the same page because DevOps means a lot of things to a lot of people. And there are vendors who say that it is their tool, right? Yeah, just buy our DevOps configuration management thing and then you're DevOpsing. No. Configuration management is an important part of it, but that does not mean you are doing DevOps. It's not continuous integration or continuous delivery. Those things are important. They are very valuable. That doesn't mean you're doing DevOps. If you just have, yes, we have the CI tool, I'm not going to name it. Great, good. It's probably better than not. It's not having a DevOps team. These images are from, as you can see, from the watermark DevOps topologies, which is a very good source of this sort of thing. Some companies say, well, yeah, we want to do DevOps. We've heard it's great. The survey says it's super useful. So we just took this team, and now there's a DevOps team. Now you have another problem. You have 3 problems. Great. It's definitely not, well, we told the ops team that they're now SREs, or they're the DevOps team. Google and Amazon have SREs. They do great, right? Twitter's got SREs. They do a super job. So we're doing DevOps, right? No. SRE and ops are totally different jobs. They're different skill sets. People can transition between them, totally. It is definitely not this no ops thing. Noops. which I don't hear much about anymore, but if you're like, well, we do DevOps because we just make all the devs do the ops stuff too, one, that means you need a lot more developers, and two, it means you've just given up on the concept of subject matter experts. You said, you know what, I don't need anybody who actually knows how servers work or how like bits flow from machine to machine, series of tubes. The devs just do it. There are places that do this successfully, 100%. That is not DevOps. If you just fire all your ops people, please don't as former ops person, that does not make you DevOps, and it probably makes, tell me if you're doing that so I can short your stock or something, I don't know. And it's not a thing you can buy. You cannot just go buy DevOps in a box. You cannot pay someone to like make you DevOps. There are companies, I'm super sorry if you work for a vendor and there's a thing out there about buying DevOps from you, sorry. I've seen pitches that just say, yeah, bring us in, we do the DevOps for you so you don't have to worry about it. Boy, it doesn't work like that. You might have consultants who help you figure it out, that's great. You can't just buy it. It's not a thing that just you wave a wand and there, DevOps, great. Scams. This is a term that was coined at DevOps Days Mountain View in 2010 by Patrick Willis and Damon Edwards. There's a great blog post from Patrick Dubois, who's one of the founders of this DevOps Days thing. And then John Willis has a really great blog post on the Chef blog from 2010. I've got links to those in my in the slide at the end. Or Calms, Jess Humble added the L. I thought clams was funnier, but for some reason nobody wanted to do that. I don't know. Those are culture. First thing first, I'm going to borrow from the Agile Manifesto here. Individuals and interactions over process and tools. You have to want to actually get these outcomes and have people bought into doing it, or you're going to have a bad day. I'm going to show you some reasons you might want to do that. Automation. Computers are good at doing the same thing over and over, basically the same way each time. And so you should allow people to not do redundant, boring tasks to 10 machines, 100 machines, 1,000 machines. Let the computers do it and let your people do the hard stuff. Lean, from Jez's edition. This is both in terms of lean software development, which is a talk in and of itself, and kind of the common use of lean of like reduce your overhead, like maybe cut out things that you don't need to do. Metrics or measurement, these are used interchangeably in that acronym. I don't remember which one is Jez's and which one's, anyway. How do you optimize? How do you know if you're doing something better if you don't even know what better looks like or what the current state is? If you want to talk about, does this change deliver any value, was this worth doing, but you have no idea if it gains you value or costs you money in the beginning, how do you know if you're getting better? Then sharing. Everyone involved in your DevOps practice, hopefully it's the whole company, but at least the people you're making do these things, should see the output. If you have metrics about capacity planning, you have how fast you're shipping software, you have customer growth, everybody involved should be able to see that so that you can, so they all know, they're on the same page about what's important. If you are, here's an example from a previous employer that I'm not going to name. The operations team had no idea when we were shipping new features, including features that were going to bring in new customers, or we're going to double how much the big customers use the site. You know where that led? Bad days. Felt bad. Or if it turns out that it takes your ops team, let's say you did not watch the previous talk and you're all on-prem, and it takes you 3 months to buy new storage systems. And your devs don't know that, and so they're writing a thing that's going to be shipped in a month, told customers it's there, that requires another petabyte of storage. That's bad. Generally, the concept is moving work to the left. This is the left being the beginning of your development or of your operation, and the right being you're done. The earlier you move any of this work, the DevOps movement, a lot of people started it as, we started at, developers do plan through release, they toss it over the wall to the operators, and the operators have to run the silly thing. And instead, DevOps is get them involved at the beginning. And part of what I'm talking about here is the move toward getting security involved in that. Because your security people can do a great job here. Also, there's a link in the notes. Dr. Dobbs, do you remember the Dr. Dobbs journal? Software development. Dr. Dobbs' journal from 2001 had an article about doing that, like moving your tests earlier in the process. This is not new stuff. So finally, 20 slides in, I get to the report that I promised you I was talking about. State of DevOps report, 2016. The 2017 one is, the survey is still out, and if you're interested in making this data better, you should take it. It's run by folks at Puppet, some people at Chef, and DORA, the DevOps Research and Assessment group. Specifically, these folks in 2016, Alana Brown, Senior Product Marketing Manager at Puppet, Dr. Nicole Forsgren, who is now at DORA full-time. She was at Chef at the time, but now she is working on DORA, the DevOps Research and Assessment thing. Jez Humble, co-founder of DORA, who has written a lot of books about continuous delivery. Continuous delivery is the most important, I'm not going to say the most important one, sorry, Jez. It's a very useful one for this field. Nigel Kirsten from Puppet. He is currently our Chief Technology Strategist. He was our CIO for a while. He's done a bunch of stuff there. And then Gene Kim, who's been involved with DORA for quite a while since the beginning, and has written books about doing DevOps-y stuff, including the Phoenix Project, which if you haven't read that, it's super. Talk about the history a bit. 2011, State of DevOps report starts. And the question was, what does DevOps look like? DevOps as a movement, there were DevOps days, all of that, but what does it look like in a large enterprise? What does it look like for people who are doing it at a large scale? And at the time, it was very exploratory. There weren't specific questions, it was just what are people doing out there? A couple years ahead, there's a lot more traction in DevOps, and a lot more companies were saying they were starting to look into it, or they were starting their DevOps practices. 2014, more and more people all the time, but we started seeing, I'm sorry, I missed this earlier. This is all those people's research. I'm presenting on it, but when I say we, I mean the royal we. I don't want to take any credit for this work. Smarter people are doing this thing. We started to see gaps in performance by a number of indicators between companies saying they're doing DevOps and who answer the DevOps-y questions, not just say they're doing it, and companies who aren't. There are distinct clusters of low, medium, and high performers based on a bunch of metrics of performance that map onto if they're doing the DevOps-y things. And there were common tools and practices in those high performers. And so there's this, I find this term kind of embarrassing. I feel like a salesperson when I say it, but like the enterprise DevOps tool chain, which is not software, it's practices that people have. And it's most of the enterprises that were the high performers are doing these things. Continuous delivery, always be shipping. Companies that are performing well are releasing software, for whatever releasing looks like, as quickly as possible. Because the smaller your deltas are between those releases, the easier they are to test, the easier they are to deploy, and the easier it is to back out or to see where changes caused problems. Infrastructure as code. Most of those companies are doing that in some form. This doesn't have to be my product now works on, whatever. Anything you're doing is good, and all of the software in that space is better than not doing it by a lot. Version control. Okay, I'm not going to ask the embarrassing question of how many of you are not using version control. Just kind of give me like a quiet nod if you're doing it. I don't want you to be embarrassed and be like, oh, yeah, we're not doing it. There are companies out there that don't have version control. That is, they don't have version control of their code, they don't have version control of their infrastructure as code, and they don't have version control of their artifacts, which means they can't answer, what did the software look like a month ago? What did the software look like a week ago? What did the software look like when this breach happened? Or when our customers, when our conversion rates dropped down? There are companies that don't do this still. And testing. Similarly, I'm not going to ask people to raise their hands. There are really companies in 2017 who are not testing their software, either automatically with some amazing continuous integration system, or even just by having a playbook of what to test. There are people releasing software, they just don't know if it works. Or their testing boils down to, yeah, our tester ran it. If that's you, I'm sorry, if I'm like shaming your company up here because you're not doing that, you can do this. You can make it better. 2015, trends continued, and we saw two new things that matter quite a bit. The middle management, it's not that the middle management is like the thing that came up, but companies that are doing well at this have buy-in at the middle management layer. Companies that said, yes, organizationally, we will do DevOps, the CTO said, thou shalt DevOps, and the middle managers don't care, it doesn't go very well. And companies, and this is a little depressing as someone who likes it from the grassroots side, companies where the developers and operations people wanted to do it, but their management, for some reason, the structure of the company didn't let them do it, had a hard time. If the head of development and head of ops disagree on what you should be doing and what your priorities are, it's hard to work together because you're encouraged to not, actually. Lean management. There's a whole talk just in about what this is, but lean management is continuous improvement and being willing to remove process, actually, if it doesn't provide value. This is value stream mapping, which again, I could give a whole talk on that, or someone more qualified than me could give a talk on that, preferably. But if that's a concept you don't know, value stream mapping, super important. 2016, the last released survey. Those trends continue. There are none of these trends I'm talking about that dropped off later, but new ones keep emerging. This is partially because we have more data, and it's because companies have been doing this longer. So companies are trying to move not just the development and testing and operations to the left, they're trying to move everything to the left. They are getting marketing involved. They're getting their security folks involved. They're getting as many people who care about the product involved as early as possible to reduce the cost of making change. Lean product management is happening a lot. I added a couple of links here because it's a very deep topic. In short, your product management team, and this may seem silly, being focused on your customer problems and needs, not just requirements you kind of came up with internally. That sounds pretty straightforward, sounds like what everybody should be doing, right? But it turns out that's new. It's not new. Some companies don't do it. I'm not trying to mock you, if that's your company. And security is finally involved. Companies are saying that they are moving their security teams earlier in the development cycle, and they're getting them involved very early in the design and test of the software, design, implementation, and test. Sorry, I just answered that question. So DevOps comes from this place where people, if you think of the old traditional way to deploy software, your devs write some stuff, your operations team, they huck it over to the operations team. Our operations team says, this is garbage, why can we not run this? And there's animosity. And so DevOps is about moving and working together. What other teams in your company might be considered like blockers? Security, right? A lot of companies, your security folks are the ones who literally say, I know you spent the last 9 months on that, no. Oh, you spent 6 months buying that new HRS system that's going to hold all of our stuff? Nobody wants to do that. I mean, clearly some people want to do that. But you can make your company better and make your practice better by getting them out of that blocker mindset and into help people make good choices and know about what they're doing. Again, subject matter experts being involved might make your software better. So the security teams need to get closer to the project start. They need to get involved in, when you're writing software in-house, because this isn't just about development, you need to get involved in design and development, right? New features, you need to talk about what are the security needs for this. Oh, you're going to store credit cards. Let's talk about PCI. You're going to store people's health data. Let's talk about what that looks like. Third-party services, when you bring them in, the security teams need to be involved in that purchasing or that, I don't want to say procurement exactly because it sounds like you just have to run credit cards, but they need to be involved in specification there. I've been in a company that literally more than a year of 20 people's work got submarined at the end at ship time because they had not covered a regulatory requirement. And it wasn't just, oh, you have to go back and do that. It's like, we can't sell that feature legally. One of us, our CTO, will go to jail. Who wants to do that? Who wants to be the one that says just all of you wasted your entire year? Sorry. Well, so it turns out that not only does that sound miserable, but doing this, doing DevOps, and having these practices of moving security earlier in the cycle actually mean you're more secure. High performers had, this is, Chris got this slide before me, which I was very sad by, 200 times more frequent code deployments, 2,555 times faster lead times, which means like faster time between idea and ship, 24 times faster mean time to recover, 3 times lower change failure rate. And that 2,555 times faster sounds kind of made up, right? It's a very specific number, but like that's not, how is that the case? Well, so here is the clustering. Lead time for changes moves from, in the low performers, 1 to 6 months for a change to go from, we've decided on this change to shipping, to less than an hour. How many of you remember last year there were like OpenSSL patches that were super critical every month, right? Well, if you can't ship, if it takes you 6 months to make a change that is coming every month, you're in bad shape, right? And your time of vulnerability, the time where that problem is available in your infrastructure, is forever, basically. Okay, so some people look at this and they say, well, but that might not be about security. That might be like code changes, right? Those things are the same, I would argue, but okay. Here's a slide. You don't have to read all of it. And let me zoom in on a couple important parts there in case they're hard to read. 50% less time spent in the high-performing group remediating security issues. How many of you have a dedicated security team at your company? Okay, cool. How would you like to double the size of that team without having to hire a bunch of people? Right? These practices mean that you can do twice as much. Or if you don't have a full-time security team, you're a smaller company, and it's somebody's part-time job, oh, look, you gain effectively a full-time person. So not only are they faster, but they're just doing less firefighting. How are they doing it? It's an integral part of continuous delivery. They are involved early in development, and they are involved often, and they're integrated in there. It's not just, oh, right, when you're working on a new feature, check in on that team. No, it's have them involved in planning, have them involved in review and demos and whatnot. Security reviews, early, very early, that don't slow down your development. Security in the daily developer work, which includes providing input during the design of the application, going to software demos, et cetera. And the security teams have built in automated testing around it. Here's a practical example of that. If you ship code that has to use SSL, and you probably have some requirement that you don't speak some terrible like export-only cipher that's 56-bit or whatever, how many of you actually test to make sure that hasn't gotten turned back on in your software every time? You would be surprised. Some config change, you upgrade some library, and all of a sudden, doing it wrong again without you even knowing. Automated testing helps that. And the security teams need to be building pre-approved, I'm going to read here, pre-approved, easy-to-consume libraries, packages, tool chains, and processes. So when people ask, how do I do an authenticated HTTPS request to an endpoint? The wrong answer is, well, you go read the OpenSSL docs, and you get writing some code. Yeah. No, there needs to be an agreed-upon place to do that, and a way to do it, which means that if you need to make changes, there's fewer places to do it, and not all your developers need to have read and understand the OpenSSL docs. Which, by the way, if anybody says they really understand the OpenSSL docs, odds are good they're wrong. Maybe they do, and they're like a superhero, but they're probably wrong. So in general, the thing to do, move all that work to the left. Thank you. These are a coworker of mine insists you have to have a cat image in every talk you do, and I don't have cats, I have dogs. So that's Kiki on the left and Happy on the right. Important links, which I don't expect you to read all of these, and remember them. I'll post at least this slide on Twitter or something. Important to note is that the 2017 State of DevOps survey is still running, and so if you're interested in it, you can provide data and help us see what is going on there. You can download the 2016 one and all the previous ones there. I have to say, because somebody complains at me every time I talk about this thing, you do have to fill in a little marketing thing, give them an email address to download that. I'm sorry. If that is a blocker for you, come and talk to me, and I will give you a PDF of the silly thing. Also, our salespeople are super friendly and say hi to them if they call you. And then other things I talked about. That's it. I don't think I have time for questions, but I'll come and do it in the, I'll suggest an open space. If you want to talk about it, come ask there. Thanks.
Thank you very, very much. Looking at those stats, my voice is going a little bit. Looking at those stats, I'm like, are you sure I can't buy this? This looks great. If someone can come up with this, I would love to purchase. All right, so now we have come to my favorite part of the conference, where we get to the heart of discussing things that we are passionate about, the Open Space Unconference. For those of you that don't know, I will explain briefly how this works. We have a number of sticky notepads and pens. If you have a topic, this is important, that you would actively like to participate in discussing, not just set a bird free, you know, something you would really like to talk about with others, we're going to have you come up and queue up over here with Vincent and give a 2-sentence pitch on why you think this idea is important to you, why would you like to discuss it, and then we will write it down, and we will take these to the lobby for voting over lunchtime. For those of you listening in the overflow room who would like to pitch ideas as well, please come on down now. We want to make sure you're included. We're ready for your ideas. After we get the ideas in, voting is super easy. You just take one of these pens that we'll leave out at lunch. You put a dot on the paper topic that you're most interested in discussing. Please, 1 dot per person per topic. Don't go dot crazy. And then we will take the most popular topics, and we've got a number of rooms around here booked. We've got 3 over here, 1 behind, 1 over here, as well as our overflow and lunchroom. So we will take those and assign them all rooms, and after lunch, and we finish the Ignites, we'll set you free to sort of make your way to the topics you find most important. All right. I know we have at least one topic coming from Bill. Who else do we have? Come on up and pitch your topic.
You already know what my first one is, obviously. I would also like to talk about security testing, static code analysis, and that kind of tooling, and what people are doing in that space, because it's super interesting to me, as you could guess.
How about you can write it down afterwards. We'll just have you come up and talk, and then we'll have you come back and write it down. There you go.
Hey, I'm proposing a topic on automated testing in containerized environments. So basically testing all your containers and how you set that up and create continuous integration around that. Thanks.
Hi, I'd like to talk about deploying code and not worrying about breaking the build.
He was looking at me when he said that. I'm like, hey, hey.
Inventory. Where is it? What is it? We've got our development inventory. We've got our ops inventory. The two don't meet. There are 15 different files. Well, 15 isn't there are more than 100 different files with various bits of inventory floating around all over the place. How do we get this all together? I want to talk about it. I hope other people do too.
Thank you, Larry.
CloudFormation. We use it a lot. I think it's pretty cool, but it tends to encourage an awful lot of copy and pasting of tedious configuration. So I want to find out what tools people are using, what techniques, what best practices, how they manage all of that. Thanks.
I'd like to talk about access control onto servers. So kind of the idea behind DevOps is everyone owns everything, but how are you controlling who gets access to what in terms of SSH or maybe AWS or cloud resources?
Not supposed to just give everyone root? I don't know.
I'd like to talk about enterprisey DevOps and all that that entails, policies, procedures, all that fun stuff.
Super fun.
Modern network fabrics, so how to make networks more accessible, programmable, not and kind of application agnostic. So something that's less of a blocker, more accessible, and yeah.
Awesome. Next up.
Hi, I'd like to suggest a talk to discuss about transitioning to infrastructure as code, especially migrating active production infrastructure into code.
So stuff breaks in production. I want to talk about how we handle incident response across the company and communicating to customers when things go down, as not just an ops problem. So,
David.
So I'd like to talk about designing a coding standard for the real world in your enterprise environment. My problem that I've seen so many times is that systems level code, Python, Perl, PHP, doesn't follow an effective standard. And I'd like to talk about the concept of designing one, enforcing it, and making sure that all of your contributors can actually work with it.
Thank you, thank you. A reminder, put your mouth close to the mic or be loud, just to make sure.
I'll try. So I want to talk about building platform invariant cloud apps. So next time Amazon is out, your app should not be.
I'd like to talk about development tools in a cloud microservices environment. So you've got all of your local developer tools. How do you actually deal with local development when half of your services now are in the cloud? You can't replicate all of that to your local environment.
Awesome, awesome.
Hi. I'd like to talk about finding the right balance between a centralized DevOps team versus a decentralized team where the DevOps team is actually embedded in the project. What works for you and what challenges exist?
It's always the question, centralized or not.
Thanks, Kelly. I'd like to discuss the application of DevOps principles to packaged goods, which ship on a less regular cadence or more like yearly, as opposed to things that can be updated live or every day, things like that.
Like things that ship on a disk sometimes?
Hello. I'd like to share and discuss ways of making Selenium end-to-end tests both deterministic and performant, hopefully.
The age-old question. Come on down.
I'd like to talk about culture and how in a company that definitely 100% does not do DevOps, how we start building a DevOps culture and bringing our dev and our ops teams together.
I want to talk about front-end databases like Firebase and how we're going to support real-time views and the different architectures that entails.
Front-end databases.
Hi, I'd like to talk about teaching the skills needed in cloud computing and DevOps and what we should be teaching in universities in BC.
How many of you here are students still in school? We got one back there. Woo! It's worth taking a minute. That's an excellent topic to think about how we get, more students involved as well.
Hi, I want to discuss on the topic of future trends in DevOps and how it's going to affect different roles, especially developers and testers, where this is going and where this is leading us.
Predicting the future state of DevOps survey.
Hi. Are you proud of your Jenkins instance? Are you ashamed of your Jenkins instance? Tell me. Confess to me. Let's talk about it.
Is that claps for proud or ashamed?
Hi. I would like to talk about accessible and democratic whiteboarding as a practice within teams.
Thank you, Emily.
Hi, I'd like to talk about rapid prototyping and validating your ideas. What technologies are there to help with rapid prototyping, and how do you move from a prototype to something long-term? Thanks.
Hi, I wanted to debate over Kubernetes and Swarm, which one to use in 2017. Thank you.
2 will enter, only 1 will leave.
I'd like to propose a session on cloud and services agnosticism. If you want to know why, ask me about how the SMS system drives the vote depended on what we did when it went down on election day.
Ooh.
I would like to talk about building a bunch of different projects. I have a bunch of projects in different languages, and I hate building all of them because my dev environment is chaos. Using Docker containers for the build process, not just as the result of the build process.
All right.
Last one. Hey, I want to talk about feedback loop in building distributed systems. So, if you have experience in this.
Anybody else? Last call. If you're thinking, oh, should I get up or not get up? Maybe I should. Any last calls? All right. So as your stomachs might be telling you, seeing as we showed up probably unusually early for some of us, potentially, it is just about time for lunch. So our open space, before you go, wait. Our open space voting will open up over lunch. I think we're going to try to use the wall in C100, or we might put some up on easels as well. We'll get those up fairly shortly for you. Food will be served outside and in C100, I believe, just across from the auditorium. For those of you that indicated you are vegetarian or gluten-free, we have done our best to accommodate and label those meals as best we could. There should also be a few extras of those for late registrations. Please aim to leave the special meals to people who have indicated dietary requirements. If you can eat anything, please eat anything except that. And have a great lunch. Nicely done, you guys, for being on time and settled. Little round of applause for yourselves. Woo! We did it! So, welcome back from lunch. Hopefully you had the chance to meet a few new people. I know I certainly did. Apologies if I don't remember all names. I will do my absolute best. I have a buffer of 3, so unfortunately the next person I meet just pops someone else off. So we're coming up to our exciting Ignite presentations. As everyone is sort of ready here, I'll quickly remind you how this all works. So each presentation is 5 minutes long, and the 20-slide deck auto-advances every 15 seconds automatically, whether you're ready or not. Dun, dun, dun. It's definitely a fun presentation to give. So today we have Adam Lefkowitz, account executive from VictorOps. We have Jan Ulrich, manager and software engineer from Salesforce. We have career coach Holly Burton hitting the stage to help you get that next promotion. Engineering manager Xander Botha from Demonware, and Matthew Fisher from Deus, ready to help make us more remote friendly. So it looks like we're pretty much ready to go. So I'm going to hand the mic to these folks, and all the slide decks will just move together. So pretty much between them, when the slide changes to this, they will hand off to the next person.
All right, hi everybody. My name is Adam. I'd like to start off my talk by asking you guys a couple of questions. The first one is, were you aware that you have something in common with these talented people? Denzel Washington, Tina Fey, Sheryl Sandberg, and Maya Angelou? Well, another question is, think back to a time when you were learning something new, or maybe talking to somebody that was smarter than you, or just sharing a piece of your own artwork, really a moment of vulnerability. Did anyone else feel like they were a fraud in that situation? If you did, don't worry, you're not alone. Denzel Washington, Tina Fey, Sheryl Sandberg, and Maya Angelou have all had those feelings in a moment of vulnerability. And to be honest, I had to get past these feelings just to get up on stage here today. I am not technical. I'm a salesperson from VictorOps. I'm terrified of public speaking, and I'm certainly not an expert on this topic. So what is it? Well, the imposter syndrome is when people view themselves as a fraud despite evidence of their accomplishments and success. And they typically dismiss this as a byproduct of luck or timing, or maybe the fact that they've actually conned everyone else into thinking that they're more talented, smarter, or more competent than they really are. And they see other people's accomplishments and attribute that to an inaccurate perception that they have a limited amount of knowledge and other people have this vast and immense amount of knowledge and talent. And that really stems from the fact that we see ourselves from the inside, but we see other people from the outside. So we're not really privy to their fears, regrets, and anxiety, although we have those feelings all the time. So we see other people, especially important people, we think we're not like them. So how does this apply to DevOps? Well, the S in CAMS stands for sharing, and it really encourages us to share what we learn, even if we're not an expert. And with the pace of technology today, we're really learning all the time. And that's really why we're all here today. You may think that a lot of the topics are over your head, but don't worry. I mean, DevOps is still fairly new, and most people don't have the experience of just attending one DevOps Days. Take a look at, take me for example. I'm not in dev and I'm not in ops, but I do help advise our customers every day on this, and I've been in this industry of Agile, Lean, and DevOps for over 10 years, so I can't look at myself as an authority on the subject. So knowing about this syndrome alone won't help keep those negative self-thoughts at bay. So when they creep up, what should we do? Well, I'd like to take the advice of the French philosopher Montaigne. So with this advice, we really can understand what grand and important people are really like. They're just like us. So the first step in really dealing with this syndrome is just to simply recognize when these inner voices are starting to creep up and tell us that we're a fraud. The other piece of advice I can give you is, although you're not really exposed to it, keep in mind that other people's minds work in much the same way that ours do. Other people are anxious. They do have uncertainties, and they have a lot of the same fears that we do. So I really encourage you to share a moment of vulnerability with others. It really helps to increase the connection that you have with them, and it also allows you to really grow both personally and professionally. And we've got a great opportunity to put this to practice here coming up in a few hours at the open space sessions. So we're not all experts on these topics, but it really is important to get awareness into how others are approaching the challenges that DevOps addresses. The other thing is, give yourself permission to be a beginner. You may feel like you're in a room full of experts, but you're going to walk away from this conference with a ton of really good ideas. The other thing I would recommend is really keep your eye out for when these feelings are coming up with other people. And if you recognize that, be empathetic and be a supporter and really provide a safe environment for them to share ideas and opinions. And lastly, next time you see this immensely talented actor, Denzel Washington, in a movie, don't forget, he poops too. Thank you.
15 free seconds.
Introduce yourself or whatever you like. Ooh. This is where I acted out.
Hey everyone, I'm Jan Ulrich. I'm a manager of Salesforce Pardot on the internal tooling team. And we work on the CI and CD pipeline as one of the things we do. So we practice continuous delivery, and so we ship about 8 times a day. And the reason we do that is because it empowers our developers. The other reason is it's actually a safer practice because there's less code going out to production with each push. So if there's a problem with it, it's much quicker to be able to roll back. It also allows us to do quicker feature releases, and we can do marketing releases behind a feature flag. We decided to do a SOC 2 certification so that to bring assurances to our customers for the trust policies that we have in place. The first thing I thought of is this might introduce a whole bunch of red tape and slow down our delivery process. So, but luckily that wasn't the case at all, because when you put these policies and procedures into place, you as the organization can really come up with which policies and procedures you want to follow. And so we had management, developers, and the compliance team come together and create policies that allowed us to continue to do continuous delivery. We did that through automated procedures. So we took practices that we were already doing and started requiring them. So require automatic tests passing before you can merge code, require linking your work item tickets before any code can go out into production, and require code reviews for everything that goes out. We also instilled code ownership to specific teams. So I'll go through all of these things. So the first one is, this is our automated testing that has to run on any branch that gets pushed into production. So the tests have to be automated there. This is, we use Jira for our work item tickets, and so a work item ticket has to be opened before it can, yeah. And we link it through GitHub pull requests, and the way that's how we enforce all these requirements, and the way we link Jira tickets is through the title of a pull request. So developers have to title it there. We use code reviews, and to do that, we're very specific about which team, the team that owns the code component has to do the reviews that go through. And the way we specify that is with the owner's file. So a repository can be owned by an entire team, or you can have subdirectories or specific files owned by other teams. And so we're putting that ownership burden onto the developers to claim it for themselves. We also have the idea of getting notifications when files go out. So say you don't necessarily want to do a code review and just get notified, there's the idea of a watchers file. We also added chat ops commands. No, this one is for, yeah, we use the GitHub interface to do code reviews. We just specify who has to do the reviews, so we kind of added on to that feature. We added some chat ops commands to the comments of the PR. So this one is an auto merge. Once all the requirements have been met, the pull request gets automatically merged. So that's one less manual step you have to go through. We also implemented a way to do an emergency merge. And this is like, let's say some part of our CI system went down. A manager could go in, do an emergency merge, and bypass some of the rules. That automatically opens up a post-mortem ticket with the security team that would have to go through what happened in this specific procedure on why we had to treat it as an emergency. We also have two-factor authentication for deployments as an extra security measure. We use push-based notification, so after you trigger a deployment, your phone will ask you, do you approve this deployment or not? And it only goes ahead if you give it that authorization. So thanks a lot, and talk to me later if you have any questions or comments about it.
We're going to do the waiting dance for a little while. Yeah. So this is the slide they put up so that I have to entertain you guys while we wait. Hopefully you find it as compelling as I do. I'm Holly, by the way. Hi. Who said that? Who said that? Hey. Cool. Okay, so today we're going to talk about getting a promotion. I'm going to give you guys a checklist. This is a 5-minute talk, so I often do this as a 3-hour workshop. We're going to really condense it down. And I just got Twitter, so you can tweet at me. There's my info. So I'm Holly. I'm a career coach for women in male-dominated industries. This applies to all you guys, too, so don't let that intimidate you. I was a mining engineer for 10 years before doing this, and I'm a huge nerd about all things employment and all things feminism, hence my new job. So today we're talking about a single step-by-step process to you guys getting a promotion. There's tons of other ways that you can do this. This is not the only way, but it is one way that I've found that you can go through and go, have I done all of these things? If not, let's make sure I have before I start complaining. So a common approach, one that you guys have probably already tried, is step 1, do really great work. Step 2, hope that your boss notices that great work. And then 3, wait for them to promote you. How many people here have tried that? Yeah, me too. Super common. And you can add some variations to this if you want to, like maybe you'll ask your boss for some sort of vague career progression in step 2, or maybe after you've been waiting, you just get disappointed and leave. How many of you guys have tried those additions? Excellent, really common too. So I don't think that's the best way to get promoted, and today I want to talk to you guys about another approach, some tweaks to that approach that I think work a little bit better. And we're just going to wait for the slides to advance, because we're constrained to this 15 seconds madness. Great, okay, so in the better approach, step 1 is still do really, really great work. There's a reason for that. If you're not doing good work, what the heck are you doing trying to get promoted? Like, solve that, get it sorted, okay? So step 1 is still do really great work. It's a non-negotiable if you want to move up. Step 2 is where it starts to become different. So I want you guys to get really clear on what your value is to the company, not just this vague, like, oh, they need developers, so therefore I'm good, I can type stuff. What are you actually doing to solve business problems? What things do you do that help reduce risk in the company or bring in revenue or reduce cost? Get really clear on it from that point of view, and if you can turn that into a dollar value, that's amazing. So it'll give you a sense of why these people actually pay you, you know, the hundreds or thousands of dollars a year that they pay you, right? Step 3, once you've got that, is to get really specific about what your ambition is. So not just like generically, I'd like to get promoted because I feel I deserve more responsibility and more money. What do you want to do in your next role? What is that role? What attributes are there about that are compelling to you? So a lot of people will go and identify a specific position that they want. You may not necessarily be able to get that exact thing, but there may be other things in your corporation that you could do that would involve all the stuff that you like that aren't that role, so get specific around what your ambition is and how that might look. Then after that, you have to go and tell people about it. So keeping it a secret is not gonna get you where you wanna go. You have to figure out what you wanna do and then go out and tell people. So tell your boss, number 1, but also tell your colleagues and your friends and anybody that might help you, because you're gonna get a whole bunch of different eyes looking for opportunities that you might grab onto. Make sense? Cool. Eventually the next slide will come. But yeah, the point here is not to have people read your mind. And then I want you guys to be really honest about your expectations. So you guys will go and create, hopefully, some sort of plan with your boss that will help you achieve that promotion that you're looking for, that next level thing that you're trying to take on. And you need to be honest with your boss about what your expectations are around that. So if it's that you need to do some additional training or that you need another project to work on that's, you know, challenging in a particular technical capacity, be honest about the fact that you want those so that you're not just sitting there behind your desk resenting your boss for not having read your mind and offered you the opportunities you feel you deserve. And then once you've done all of those things, you have to consistently go out and advocate for yourself. So be on the lookout for opportunities and then be that squeaky wheel that gets the grease. Be like, I want to do that. I want to do that. Put me up for this role. Put me into that project. So be the person that's making that happen. If you guys do this plan, I think you'll have more control over the outcomes of your promotion. You'll definitely have a more transparent and a better relationship with your employer. And I hope that you guys will find this better than just hoping people will read your mind. So the checklist again is 1, do really great work, get clear on what your value is, get clear on your ambition, tell people about that ambition, get honest about your expectations, and then go out and advocate for yourself. Excellent, so that's the list. If you guys want to know more about this, if you want to talk more than we have for just these 5 minutes, you can get in touch with me. There's about 1 million ways to do it. I'm also on Twitter, like I said, and I'm happy to take questions after. That's it. It's an extra long slide.
I'd like to use your screen as a stand, if I may.
Okay.
I won't touch the keyboard.
Yeah, because that.
I'm the loser with the notes, but you don't want to look at me. You want to be looking at the screen anyway, so. I'm going to go now.
Go ahead.
All right. So, hi, I'll get the hello in before my slide starts. That'll help me a lot. I'm here to tell you how in less than a year, a small team at Demonware radically changed the way we build, deploy, and run online video gaming services. For the last 10 years, Demonware has provided the online backend for some of Activision's most beloved franchises like Call of Duty, Guitar Hero, and Skylanders. We've shipped over 100 games, all of which are still running, and we've been successful. But as it happens, inertia nips at the heels of success. And with inertia comes resistance to change. We were becoming victims of our own success. We went from procedure to model-driven configuration management, deploying RPMs to bare metal, and later on VMs using tools like Puppet. But even the Puppet master cannot be all-seeing and all-knowing, and cannot prevent entropy in a system that is forever evolving from an initial state. And so as the entropy, or simply the measure of uncertainty or perceived chaos, increases, so does the effort of maintaining service reliability and availability in the face of inevitable change. Chaos threatens at every turn. And you know something is wrong when a small configuration change ends up looking something like this under the hood. In business, and especially in the business of technology, value is locked up in change. But inertia and entropy are no friends of change. Our mission had become clear. We needed to unlock the latent value in change by building an operations platform that eats change for breakfast. But how do you overcome entropy? In short, you don't. You avoid it, which you can only do if every state of the system is an initial state. Now, sure, there's always a point at which this doesn't hold true, but containers and everything as code gets us a lot closer to that ideal. How do you overcome inertia? Peter Drucker said to be change leaders, enterprises have to focus on opportunities. They have to starve problems and feed opportunities. That struck a chord. We knew we needed radical change, but we couldn't bet the farm on the latest craze, not even if it's Docker, Docker, Docker. So we look to the wisdom of folks like Taleb and Reinertsen, who talk of barbell strategies and asymmetric payoff functions, which boils down to create opportunities for big payoff and known limited downside. And this is where things go south, because my page won't flip. We created a project called SkyPilot. We piloted continuous delivery of Skylanders Imaginators in scheduled containers on cloud infrastructure with a fallback to our data center. So Thoreau, who allegedly sucked the marrow out of life, said, "Men have become the tools of their tools." And maybe he was right after all. Maybe we had become the puppets and were no longer the masters. Maybe it was time to overthrow the puppet master. Maybe it was time to contain chaos. There's supposed to be awesome audio here. We're the Chaos Trap team, whoa! But that didn't happen. And we did contain chaos. We went to the clouds using AWS. We containerized our services using Docker. We lay CI/CD pipelines using GitHub and Jenkins. And we built a production-ready operations platform using CoreOS, Marathon Mesos, and Golang. And in October, together with our studio partners, Toys for Bob, we successfully launched Skylanders Imaginators, to the delight of crazed fans, many of whom had to wait for Santa before they could play the game. And there's no audio, so I'm going to try and do this thing. Hyperventilating. I'm so happy. I'm so happy. That's kind of what it was like. Was it all smooth sailing? Of course not. Mistakes were made and lessons learned. For example, the container scheduler will punish you for stupid mistakes, like running out of disk space. And in an auto-remediating system, it's easy to deprioritize collecting debug information. Don't do it. Hammering the Docker daemon with API calls is a bad idea when your health checks depend on it. And respect AWS rate limits, for they will not respect you. Do regular demos so others can join the ride. And run training and drills before you go on call with brand new tech. Double down on RCA diligence and hygiene. Reduce risk and uncertainty as early as possible. Resist the urge to onboard new customers prematurely. And close out your pilot project with an objective, transparent review. Summing up, we did it. And we're not actually Skylanders or superheroes. You too can pilot change in your organization. So if you'd like to learn more about the Sky Pilot project, whether it be technical details or where we're headed next, please come by our table. We'd be happy to chat. Thanks.
First Ignite talk. Woo! Hi, Mom. So my talk is on the remote-friendly office. Image was done in like 5 seconds with Photoshop, but a little bit talk about myself as it comes along. There we go. So a little bit about myself. I'm Matthew Fisher, Bacon Gobbler on GitHub, on Slack, on a couple of other channels. I am a sole proprietor over here, and I work on my own, and I'm working remotely now for about 4 years. So I have a little bit of how to help. So being remote is very wonderful. It's great to work there. It also sucks. I want to underline what kind of sucks after the times that I've been working remotely and what we can do to kind of, what are some good suggestions to fix those. So a couple of things that suck. Missing out really sucks when you're working remotely. Company lunches during all hands, impromptu coffee runs, kind of that office magic that everyone really loves when they go to work. Being invisible to the rest of the company, it kind of sucks. Feeling left out, impromptu breakout sessions like, hey, tap on the shoulder and do you want to work on something and do you want to figure this problem out? Losing productivity. It's a lot slower to go over chat than it is to go and talk to someone. So different things like that. It's not cut out for everyone as they're working on remote. Social perceptions. When I go up to someone and talk to someone about, I'm a remote worker, I work from Canada. Yes, I do wear pants every day. We are not more socially awkward than everyone else. We still get out and talk, and yes, we do play Rocket League on work hours, on lunch breaks. And VPN, if you're in a bigger company and you have to VPN into the network, that really sucks sometimes too, because some internal networks aren't on there, and your software administrator becomes your BFF. So how do we fix this problem? And so what are some of the good examples of what remote work looks in a perfect world? Communication is by far the biggest thing that I've found is the most underlying way of being a successful remote engineer. Getting comfortable with Slack, IRC, HipChat, whatever your company uses. Live it, breathe it, love it. But not too much communication. You don't want to be talking 24/7 because when you're working from home, it's very hard to disconnect yourself from work sometimes, so be defined with that. Don't ping after work hours. We still have working from 8 hours a day. Being felt included. Flying down to the office is kind of nice to go and see everyone face to face every once in a while. Water cooler conversations that you can say, hey, this is what I've been working on outside of work, and having those kind of conversations is nice. One-on-one meetings with your boss, of course, is also nice. You don't get to see them like if they're frustrated at work after 8 hours, so getting to know their burnout, their disputes, or anything like that is nice. Daily stand-ups. This may honestly be the only time that you will ever have any social engagement with anyone at work. Have that camera on. That is really cool to have that kind of face-to-face with people that you're working with today. And make them feel invited to the office. Have comfy beanbags when they're coming along. Make them feel invited. Free coffee, as always, is really nice. And so, team building exercises. Off-site show and tells. Again, this is about getting that human connection that you don't normally get when you're working remote. You don't get to talk to these people every day. Local meetups, if you're into that, sports team events, anything like that. And just like good remote employees, what I mean by that is not people who are super productive and who can work on their own. It's people who are willing to take the sacrifice of remote work and who are suited for that in the sense that they can work without being with people. And enable this kind of freedom along those lines. So like working from a cafe, it might give you a nice social change in things. So I'll carry on with that. So the TLDR of this is making comfortable, decent candidates who are good for remote work, who are comfortable with that, embracing it wholly as a company so they feel included with everyone around them, and save your barista. Because they're going to be talking to them very often if that's the only social engagement they get. So, thank you.
Wow, those were awesome Ignites. Even for you first-timers, amazing job. Actually, let's give all of our speakers today a round of applause. Yeah. Thank you guys so much for all the hard work you spent developing this content to make a connection with our audience, so thank you. Now the part you've all been waiting for. Now we move into the free-form section, the unconference. Today we have 3 time slots set aside in the for the stuff that you voted on over lunch. There is no need to return to the theater in between or anything like that. We will try to have organizers in every space to remind you when to change rooms, but please feel free to keep an eye on the time yourselves, and keep your eye out for when it's time to move or just change topics in the same room if things are moving on to the next topic. We'd also like to remind you to be collaborative. It's hard in a group setting for everyone to get to say something, but if people look like they want to participate, make sure you give them a hand so they can get what they want to say heard. So now I have the lineup of the first set for the first hour. We will go 2 o'clock, 3 o'clock, 4 o'clock, and then we'll meet back here very briefly at 5 for a quick goodbye and instructions for how to get to the party. All right, so on my right, there are 3 rooms in the 200 series that are ours. We will also have these up on the whiteboard outside. I'll just give you a heads up now on where you might like to go. So 215 is rapid prototyping. 225 is centralized versus decentralized DevOps, or just centralized versus decentralized teams. 235 is programmable networks and application agnostic network fabrics. So C485 is behind the stage, quite a big room. We'll be talking about testing containerized services. On our left, we have C440. That would be DevOps culture talks. We combine a couple topics here, so if you'd like to talk about culture, that would be a great spot to go. In the lunchroom across the hall, we will talk security testing and analysis. That would be C100. And in the overflow room, we will have teaching DevOps and cloud computing, kind of intro on how to do. And then in the main theater here, we'll talk about local development in a cloud microservice world. C100, that was the lunch overflow room, also will have the topics up on the board, so between sessions around 2 o'clock and around 3 o'clock, that's a good spot to go and take a look at what's next. We will also try to tweet them up on our Twitter. That would be DevOps YVR. Thank you, everybody.
No one agreed with a couple things. Except for that one slide. Yeah, all the Salesforce ones.